Hello and welcome to the Ruby for Beginners course. You might ask, what will I learn in this course? Well, first of all, I want to let you know that you're going to get some insight into how programmers approach their problems. Problem solving is the most important skill for a programmer. And secondly, this course is a project-based course. So that means we're going to do lots of exercises as well as 10 awesome projects. We're going to be setting up the Ruby development environment. We'll install the latest Ruby package to our system, and there will be instructions on how to install Rubies on Windows, Mac, as well as Linux. So when we're developing Ruby programs, we need a development editor. The Aptana Studio is one of the best development editors for Ruby programming, and we're going to be using that in our projects. In this course, we're going to learn the fundamentals of Ruby development. We'll learn what are variables and data types, how to do the arithmetic operations, and string manipulations. Then, we will learn conditionals and loops. Then we're going to be using functions, and we'll also learn how to import modules. The next topic is commonly used data structures of Ruby, arrays, and hashes. Then we're going to learn how to handle files, both reading and writing of files. And then finally, we will start to learn an advanced topic, object-oriented programming, which you may have already heard of. You ready? Let's go. So now let's go ahead and download and install Ruby on Windows. Installing Ruby on Windows is indeed very easy. First, you open the download page of Ruby, which is rubyinstaller.org/downloads. And again, there are multiple versions of Ruby. So we're going to use the latest stable version of Ruby, which is 2.5.3. You can also download the dev kit included version, and it provides the biggest number of compatible gems, but I just want to install for our purposes the basic one. So you can go ahead and download the compatible version for your architecture. I'm using an x86 architecture, so I'll download this one. And after downloading the installation package, just simply click on the package to start up the installer. And I'll choose the default installation. You might want to customize installation, unless you're going to keep up with me. Now, I don't want to install MSYS2 or MSYS2 right now, so I'll just uncheck it. MSYS2 is a toolchain which is required to build native extensions for Ruby. So after finishing the installation, we now have a fresh version of Ruby. So why don't we go ahead and verify it? Open up the command line, hit Windows and R simultaneously, and then type cmd and enter. Ruby -- version shows that the latest version is 2.5.3. So let's download and install Ruby on Mac. So here's the download page of Ruby, ruby-lang.org, and click on the download button. Now here there are multiple versions of Ruby, and we're going to use the latest version of Ruby, which happens to be 2.5.3. Now we have several options to download Ruby on OS X machines. And let's choose the RBEnv. It's a third-party tool, and it's very popular. It allows us to install multiple versions of Ruby on the same machine. So open the link, and it's a GitHub page. And you can read the instructions as to how to install the tool. Now, the recommended way is using the Homebrew tool. So let's open up the terminal and copy and paste the command. And then after downloading the package, run the second command. Now the output says that we need to append the following code to our bash profile file. So let's go ahead and copy it and open the bash profile using a text editor. I'm just using Vim. Paste it, and now we can close the file. Now, we should restart the terminal to apply the changes. And, yep, there it is. So now we can go ahead and use this script to verify the installation. Let's see, and yeah, everything is A-OK. So now we can install the latest version using the example command. The latest version, as I said earlier, is 2.5.3. Downloading and installing may take a while. But then, after finishing the installation, we'll now have a fresh version of Ruby. So let's verify it. Ruby -- version shows that the latest version is 2.5.3. Now let's download and install Ruby on Linux. So this is the download page of Ruby, ruby-lang.org, and click on the download button. Of course, there are multiple versions of Ruby, so we're going to use the latest stable version of Ruby, which happens to be 2.5.3. And now we have several options to download Ruby on Linux machines. We're going to choose the RBNV. That's the third-party tool. It's very popular, and it allows everybody to install multiple versions of Ruby. So if we click on the link, you'll notice it's a GitHub page, and it has the instructions of how to install that tool. Now, we can use an automated install script, so you can click on the link, and the instructions will show you two options. So I'm going to choose the second one. In the first option, CURL might not be installed in your system. So let's open up the terminal, and we'll copy and paste the command. Now, did you see that it finished with an error? So we'll check it again with a verify script. Let's copy and paste the command. And yeah, see right there, it says that we need to add RBNV directory to global path. So let's head back to the documentation page. There is a command to add the directory to the global path right here. So copy and paste the command. Now, of course, we should restart the terminal to apply the changes. Great, so now let's go to the other page. Copy and paste the verify script. And now we need to run the init script. So copy and paste the command. Now the output says that we need to append the following code to our bash profile file. So let's copy it and open the bash profile, or bash RC, using a text editor. And yes, bash RC also works, but I'm using Vim. So paste it and just close the file. Now we should restart the terminal so that the changes are applied. So let's check it again with a verify script. And sure enough, everything is A-OK. Now we can install the latest version using the example command. And the latest stable version is, guess what? 2.5.3. Now downloading and installing may take a while. And okay, there it is after finishing installation. Now we have a fresh version of Ruby. So why don't we verify it? Ruby -- version. What? We got an error. Actually, it is installed. We need to set this version to be global. RBNV global 2.5.3. And check it again. Ruby -- version shows the latest version, 2.5.3. So if you were paying attention earlier, Aptana Studio is one of the best development editors for Ruby programming. We were talking about, I just mentioned it, but now we're going to go ahead and have a look at it. You can download and install it from aptana.com. One of the great things about it is an open source product. So you can click on the download link, and it opens a GitHub page. So open the releases page and click on package link. So I'm using a Mac here, so I'll download the .dmg package. Yeah, and it takes a while. That always depends on your network speed. But now you can see that the download is finished, so let's open the executable file and copy Aptana Studio to the Applications folder. Now let's open Aptana Studio in the application list. And it asks for a workspace folder. That's okay. And yeah, so now it looks ready to create projects. So why don't we go ahead and create a test project? The left window is what's called the Project Explorer. And right-click on Project Explorer or the File menu on the top left corner. So Ruby Project, Default Project. Name is Test, and it shows the location of the project. Finish. And there it is. The test project is indeed created. So now let's create a Ruby script. Right-click on the project name. Select File. File name is Hello, and the file extension is RB. So yeah, Ruby scripts always have the RB file extension. So let's print something. So in Ruby, if we want to print something in the console, all we need to do is puts, open quotes, and Aptana automatically adds close quotes. So let's write, hello, Ruby. I hit Command S to save the file, and right-click on the green button above the Project Explorer, Run as a Ruby application. And then down here in the bottom, you can see that we get a Hello Ruby. So that's it. Okay, thanks for taking the course. I'm just kidding. We've only just installed the Aptana Studio, which is an awesome IDE. So now let's start to learn about programming. We need to know how a programmer thinks. Programmers have to develop, I think, a different type of thinking. This type of thinking combines some of the best features of mathematics, engineering, as well as science. When you dive deep into the programming world, you're going to notice that your perspective shifts. You denote ideas like a mathematician, design things and build systems like engineers. observe and understand complex systems like scientists, and you're going to love it. So a program is a sequence of instructions. These instructions specify how to perform computations. In general, every program seems to have a few basic instructions. Takes input from a keyboard, file, or some other source. Shows input on the screen or sends data to a file or some other device. Performs some basic mathematical operations such as addition or multiplication. Checks for conditions and executes statements according to decision. And then repeats performing some of the actions. Almost every program has these general instructions. Now, they may change in details, but generally that's about it. So yeah, take it away. We are now ready to write our first program. So let's go ahead and open up Aptana Studio or your favorite development editor. So we'll need to create a new project. So you right-click on the Project Explorer and create a Ruby project. You can do it also from the File menu. Let's just name this First Project. Then create a new file. File name is first_program. And file extension is RB because Ruby scripts have the RB file extension, correct? So now we're ready to write our first program. But what's our first program going to be? Yes, you guessed right. If you know anything about the history of computing, Hello World will be our first program. People use the Hello World phrase in their first program. So, how do we do that? We will use the puts function to display results. So let's write the code. Puts, open quotes, hello world, close quotes. Yeah, that's all. So let's run it. Now to run it, just right-click on the file and click Run as a Ruby application. And it shows the results on the console window. Now, there are several ways to print out values in Ruby. First, we can use the print function. Print hello world. We can run the program using the above buttons. Just click on the green Run button, and it shows some run configurations. So click on First Program, and it shows a result. Now, the difference between the put and the print functions basically is that the puts function adds a new line character at the end of the printed value, while the print doesn't add anything. Remember that. Now, there is another way to print out the values. We can use the p function. P, hello world. And click Run, and it shows the results. The p function shows values in quotes. So, for example, in a string representation. And as you notice that the p statement showed the value on the same line with the print statement because print did not add a new line. Okay, so it's a simple program and it just prints hello world. What else can we do, you say? We can run our program on the command line. So open up your terminal. Ruby, and the next input will be our first program. Now, we've used default settings for the workspace, and that's of course located in the Documents folder. So the file name is Documents/Aptana Studio Workspace /first_program.rb. And enter. And then it shows the print statements. So we can run our Ruby scripts just like that. Why don't we have a look at the Ruby help output? Ruby --help. And that shows all the available command options for executing the script. Now we can run these statements on an interactive Ruby shell, or IRB. IRB stands for Interactive Ruby, and it's a tool to interactively execute Ruby expressions read from the standard input. So let's have a look at that. Open your terminal, type IRB, starts the interpreter, puts hello world, and shows a result with a new line. So print hello world, and it shows a result without a new line. P, hello world, shows and returns a result. Now, programming is error-prone. So when writing codes, we might just make a few errors. Programming errors are, of course, called bugs, and the process of tracking them down is called debugging. But there are three kinds of errors. Syntax is a set of rules. So when we violate these rules, a syntax error occurs. So why don't we see an example of that? Let's open up Interactive Ruby Shell. And Interactive Shell executes codes and shows the results immediately. 5 shows 5. 5 plus 9 shows 14. And just like that, we can do mathematical calculations. So 5, multiply sign, open parens, 2 minus 5 shows minus 15. And yes, we just use parentheses to order the calculation. Let's do another one while we're on a roll. 5, multiply sign, open parenthesis, 3 plus 7, close parenthesis, close parenthesis. See, now that shows a syntax error. That last parenthesis is illegal, so the interpreter just gives you a gentle nudge. So the second type of error is a runtime error. These types of errors do not appear until the program starts to run. These errors are also called exceptions. These types of errors will not generate any error message or any other error output. The program runs successfully, but it doesn't necessarily do the right thing, because the program is logically wrong. So let's continue on to our first project, because we're going to get some good things covered. Comments are lines of annotations that are ignored at runtime. Comments are used in programming to make codes more understandable. When somebody tries to understand codes, the comments help to figure out what these codes actually do sometimes. A single-line comment starts with a hash, extends to the end of the line. Hash. This is a comment. We can also use them as an inline comment. We can comment on multiple lines using begin and end as a syntax. The begin and end lines must be at the beginning of the line. Multi-line comments are rarely used. I just wanted to give you a heads up. In the programming world, variables are names that reference some other value. If you want to save some value, assign value to a variable. In other words, variables are just boxes. We'll use them to put something in and save it. So let's look how to do that. Let's start with our first program. We'll use the print function to display our message. Let's create a variable called message and assign our hello world string. Equation sign means value in the right side will be saved to the variable on the left side. Okay, so we assigned our message. Now we can use it in the print function. And sure enough, the results are the same. So let's try something else. Let's say I want to save a number. A equals 5. B equals 3. And show a value of A. A multiplied by B. Okay, we multiplied two values using variables. Now let's have a look at naming of these variables. So let's create a person variable, and let's say the value is Jack. We can also create a person variable by typing a capital P and assigning its value as Tom. So you see that Ruby is case sensitive. So let's create a variable and start it with a number. Okay, see, now we get a syntax error. Variable names cannot start with a number. However, at the end of the name, numbers can be used. So why don't we try the same with a sign? Person question mark equals Jane. And there's another error. So signs are not allowed in variable names either. So what about the underscore sign? Person underscore equals Brian. And that's okay, so no errors. Underscores are commonly used in naming variables, so it is not an illegal issue. Person underscore 3 equals Brian and shows value. Name underscore surname equals John Doe and shows value. Now let's try something different. Class equals programming. And we got a syntax error. Else if equals test. And we got a syntax error. Okay, so why do these errors occur? And why am I sitting here making them? I'm showing you that, as in just about every other programming language, Ruby has some reserved words. And these words are called keywords. You cannot use them as a variable. All right, let's move on. Data types in Ruby represent different types of data like text, strings, numbers, etc. All data types are based on classes because Ruby is a pure object-oriented language. There are different data types in Ruby. So I want to show you by opening up Terminal and type IRB to start an interactive Ruby shell. And let's try to understand some Ruby data types. In Ruby programming, everything is an object and it belongs to a class. We can determine a class name by calling up object.class. So hello in quote class shows a string. And what about numbers? 5 class shows integer. Now in Ruby you may see underscores in literal numbers. These underscores are ignored and they are used to make big numbers readable. So 1,000,000 with underscores is also an integer. 5.45 class shows float. Boolean data type represents only one bit of information, either true or false. So why don't we go ahead and check them? True class shows true class. False class shows false class. Open bracket. 1, 2, 3, close bracket. Class shows array. Now, an array stores data. Data in an array are separated by commas in between them and enclosed within square brackets. Open curly brace, name, preceded by a colon, John. Close curly brace, class, shows hash. Now, a hash assigns its values to its keys. Okay, so arrays and hashes are collections of objects. Arrays are ordered collections of objects. Hashes are collections of key-value pairs. Colon, name, class, shows symbol. So symbol is a data type specific to Ruby. Symbols are lightweight strings and used to represent other objects. A symbol is preceded by a colon, and symbols are used instead of strings because they can take up less memory, so symbols have much better performance. So harken back to earlier, and we've done a few examples with some numbers, but let's see what else we can do. Now, you know that operators are special symbols. We can use them to perform arithmetic or logical computations. The value that the operator operates on is called the operand. Arithmetic operators are used to perform mathematical operations. Pretty straightforward, huh? Plus adds two operands. Minus subtracts the right operand from the left. Asterisk multiplies two operands. Forward slash divides the left operand by the right one. Double asterisk, exponent, left operand raised to the power of the right one. Percent, modulus, remainder of the division of the left operand by the right. So why don't we go through a few examples? Open up the terminal and type IRB to start an interactive Ruby shell. 3 plus 5 equals 8. 7 minus 2 equals 5. 4 multiplied by 5 equals 20. 4 divided by 2 equals 2. 2 double asterisk 3 equals 8. And 2 to the power of 3 is 8. 4% 10 equals 4. Because the left operand 4 is smaller than the right operand, so 10. So the remainder of the division is the same, 4. 8% 4 equals 0. 5% 4 equals 1. And that is because we divide 5 by 4 and we get a remainder of 1. Assignment operators are used to assign values to variables. As you can see on this table, we can use all the arithmetic operators as assignment operators. So actually, it's just a form of shorthand. So why don't we make up some examples? Open up the terminal and type IRB to start an interactive Ruby shell. A equals 1. A equals A plus 1. And A is now 2. So A plus equals 1. A is now 3. That's the same as the long form. So let's see a few others. A equals A minus 1. So A is 2. A minus equals 1. And that makes A mean 1. So A equals 2. A equals A multiplied by 5. Now A is 10. So in a pretty quick way, A asterisk equals 5. We'll get 50. Division operator. A equals A divided by 5. A is 10. So division in a short way is A is 2. A is 3. What about exponential? So A equals A, exponential operator 2, and the result 9. So a shortcut is A is 81. and the modulus operator. A equals A, moduled by 2, and now A is 1. So assigning the old value 81 and doing a shortcut, that makes A is 1. And yeah, that's about it. We will be using these assignment operators a lot in upcoming assignments. So Ruby supports the parallel assignment of variables. That means that we can initialize variables with a single line of code. So why don't we work up some examples? Open up the terminal and type IRB to start an interactive Ruby shell. So A, B equals 4, 5. Assign each value to each variable. A is 4, B is 5. Now we can swap values using parallel assignment. A, B equals B, A. A is 5, B is 4. We can assign one value to all variables. A equals B equals 5. A is 5, B is 5. We can assign values to a single variable. A equals 1, 2. A is an array. Now we can assign values of an array to variables. A, B equals 1, 2, 4 as an array. A is 1, B is 2, and 4 is lost as no receiving variable. All right? So we can handle this situation. A, B, asterisk C equals 1, 2, 3, 4 as an array. A is 1, B is 2, C is an array and includes the rest of the values. So we need comparison operators to compare values. It either returns true or false according to the condition. Arithmetic operators are used to perform mathematical operations. The greater than symbol returns true if the left operand is greater than the right. The less than symbol returns true if the left operand is less than the right. Double equal returns true if the operands are equal. Exclamation point and equal symbol returns true if the operands are not equal. Greater than and equal returns true if the left operand is greater than or equal to the right. Less than and equals returns true if the left operand is less than or equal to the right. Now, a combined comparison returns 0 if the first operand equals the second, 1 if the first operand is greater than the second, and -1 if the first operand is less than the second. Case equality. It's used to test equality within a clause of a case statement. Check the same type and value. Returns true if the left operand's value and type equals the right one. Check the same object ID. Returns true if the left operand and the right operand have the same object ID. So now that we've got that in the clear, why don't we have some concrete examples? Open up the terminal and type IRB to start an interactive Ruby shell. So 4 greater than 3 returns true. 2 less than 0 returns false. 3 equal to 8 returns false. 7 is not equal to 9 returns true. 4 is greater than or equal to 8 returns false. 6 is less than or equal to 9 returns true. 3, combined comparison sign, 3, returns 0 on equality. 3, combined comparison sign, 0, returns 1 if the first one is greater than the second. 4, combined comparison sign, 8, returns -1 if the first one is less than the second. String as a class, case equality, foo as a string, returns true. So now, one way to think about that is, does the second operator belong to the first one? So order is important. 5, case equality, range 1 to 10 returns false. Actually, this range includes 5, but usage order is not correct. The value should be in the second operand. So let's check the equal operator. A is 5, and it is an integer value. B is 5.0, and it is a float value. A equals B returns true. A equal question mark B returns false because they have different types. A is test. B is test. A equal question mark B returns false. A equal question mark B returns true. Values and types are the same, but the object IDs are different. A, object ID. B, object ID. They are different. So if we make a one-line assignment, what will happen? A equals B equals test. A equal question mark B returns true because they have the same object ID. So let's check them. A, object ID. B, object ID. And sure enough, they are the same. So now let's get into logical operators. And returns true if both operands are true. Or returns true if one of the operands is true. Not returns true if the operand is false. Logical AND returns true if both operands are non-zero. Logical OR returns true if one of the operands is non-zero. Logical NOT returns true if the operand is false. Great, so let's open up the terminal and type IRB to start an interactive Ruby shell. Now, let's say we have two variables. A is true, B is false. A and B shows false. A or B shows true. Not B shows true because B is false. A, logical AND B shows false. A, logical OR B shows true. Logical NOT A shows false because A is true. So there are also some special types of operators in Ruby. Open up the terminal and type IRB to start an interactive Ruby shell. Sequences are successive values consisting of a start value, an end value, and a range of values in between. We can create sequences using range operators. Ranges are just state, start, and end values. They don't save all values. So we need to use other methods to get those values in our wanted format. The two-dot form creates a range, and the end value is inclusive. So 1, 2.5, 2a is a method that creates an array of range values. The 3-dot form creates a range, and the end value is exclusive. 1 3.5 creates the array, and 5 is not included. We can use range operators for strings as well. A 2.z to A creates all letters. AB 2.yz to A creates all Cartesian results. A equals 5. Defined question mark, A returns true and says it's a local variable. Defined question mark, $_ returns true and says it's a global variable. It holds value of the last line read from the standard input. Defined question mark, B returns nil because it's not defined. Defined question mark, puts returns true and says it's a method. Defined question mark, puts B returns nil because B is not defined. So open up the terminal and type IRB to start an interactive Ruby shell. And why don't we do some arithmetic operations? 3 plus 2 equals 5. 3 plus 2 multiplied by 5 equals 13. Wait a minute. Didn't we expect 25? Why is that? Because multiplication and division are higher precedence than addition and subtraction. So then how do we get the correct result? With a parenthesis. That's right. 3 plus 2 in parentheses multiply by 5 equals 25. All right, now that you're with me, let's do a more complicated one. 10 multiplied by 4 minus 4 divided by 2 equals 38. And yeah, we already know the rules of precedence, but it is not easy to read and understand. So let's do it in parentheses. 10 multiplied by 4 in parentheses minus 4 divided by 2 in parentheses equals 38. So yeah, with the parentheses, it's actually easier to understand. 2 power 2 plus 1 equals 5. But we wanted 2 to the power of 3, right? So 2 power 2 plus 1 in parentheses equals 8. Got the right result. 3 power 2 multiplied by 2 equals 18. And yes, the exponentiation operator has a higher precedence. So 3 power 2 multiplied by 2 in parentheses equals 81. Operators with the same precedence are evaluated from left to right. 2 power 3 power 2 equals 512. Why is that? Well, I just said that the operators evaluated from left to right, so the result should be 64. Because exponentiation is an exception for this particular rule, it is evaluated from right to left. All right, so 2 power 3 in parentheses power 2 equals 64. So we are now ready for our first project. I'm so excited. It's going to be a BMI calculator. You know what BMI is? It's the body mass index. It's basically a measure of body fat based on height and weight that applies to adult men and women. BMI is calculated by dividing your weight in kilograms by your height in meters squared. It gives you an idea of whether you're underweight, a healthy weight, or overweight, or perhaps even obese for your particular height. The BMI is just one type of calculation to help health professionals assess the risk for a chronic disease. So why don't we start coding? Open up your Aptana Studio, or whatever your favorite development editor is, and let's create a Ruby project. Project name is BMI. And now create a file. File name is main.rb. So first of all, let's inform the users about our program. Puts body mass index, BMI Calculator, and yeah, so basically the BMI calculation gives people an idea that you belong to a particular BMI category. So we're going to have to show some BMI categories. Puts body mass index, categories, puts severe thinness, if less than 16, puts moderate thinness, if between 16 and 17, puts mild thinness, if between 17 and 18.5, puts normal, if between 18.5 and 25, puts overweight, if between 25 and 30, puts obese class 1, if between 30 and 35, puts obese class 2, if between 35 and 40, puts obese class 3, if greater than 40. And I think that's about it. So now we need to take inputs from the user, right? But how are we going to do that? There's a function called gets in Ruby, and that's how we're going to do it. So let's print height in centimeters. The print function does not add a new line, so it looks better while taking inputs from the user. Height equals gets. And then the gets function returns the input with a new line character, so we need to get rid of it. Now, we can use the chomp method. BMI calculation uses meters, so we need to convert it to meters. If we use integer values, decimal values will be omitted, right? So we need to convert it to, yes, a float. Now we can use 2f as our method, and as you can see, we can call this method after another method. These types of method calls are called chaining methods, and we're going to see that in detail in the upcoming lectures. But for now, we have height, so let's take weight from the user input. Print weight in kilograms. Weight equals gets. Chomp to float. Now, let's calculate BMI. So BMI equals weight divided by height divided by 100 to get the value in meters, exponential symbol, 2 to get the squared value. So now let's print the result. Put BMI equals BMI in interpolation. So we can show values in strings through this notation. And yeah, our program seems to be completed. So let's save it and run it. So let's enter 185 centimeters as our height and 75 kilograms as our weight. And sure enough, it shows a result. So we're in the normal category. Why don't we celebrate by having a snack? Now let's move on. Strings. We've already learned a little bit and used strings in previous lectures, but I want to show you what else we can do with strings. So strings is one of the most used data types in Ruby. And right now I'll show you some of these details. First, what do? Yeah, open up a terminal, type IRB to start an interactive Ruby shell. Now we can define strings with single quotes or quotation marks. Name equals John. We can use string interpolation to combine strings. Puts hello, name in interpolation structure, shows hello John. We can have actual code inside the interpolation. Puts result 5 plus 9 shows result 14. Message equals Ruby is your best friend with a new line character and at the end of the string. Message length shows the string length. We can also use size. Message size shows the string length. So strings are sequences of characters. We can use index to get the characters. Message at index 0 shows the first character of a string, R. Indexes are 0-based. Message at index -1 shows the last character of the string, which is a new line character. We can use negative indexes. We can extract a part of the string. Message 0 to 4, start index 0, end index 4 shows Ruby. Now we can also use ranges. Message 5 to 20 shows the result. We can use the slice method. The square bracket syntax is an alias for slice. So message slice 0 shows the first character of the string. Message slice 0 to 4 shows Ruby. Message slice 4 to 16 shows the result. Message split shows an array of words. By default, split will use a space as the separator character, but you can pass an argument into this method to specify a different separator should you need to. Message split is shows the result. Now we can use the chars method to make a character array from the string. Message chars shows the character array. We can count characters using the count method. Message count y shows the count of the y characters. The upcase and downcase, these are methods that convert the string to upper or lowercase letters. Message uppercase shows the string in uppercase. Message downcase shows the string in downcase. The capitalize method returns a new string with the first character capitalized. And message capitalize shows us the result. So, as I said before, if you remember, everything in Ruby is an object, right? So in Ruby, object, everything is an object. Almost all built-in methods return a new object. So if you want to modify the original object, you can use equivalent methods which are called bang methods. So they'll end with a bang or an exclamation mark, right? So let's modify the original message. Message, capitalize, with exclamation mark, bang, shows the result. So let's check the original message. And there it is, it's modified. Ruby provides both methods, so we can choose the one that fits our needs best. But we really need to be careful because these methods have a number of disadvantages. Message swap case shows the string with the casing swapped. Sometimes we'll need to remove characters from the end of a string. That's where the chop method comes in handy. It'll remove the last character from a string, especially useful for removing the new line characters. Message chop. It removed the new line character in the string. So let's modify an existing string in place. Message chop bang method modifies the string. The chop method can remove multiple characters from the end of a string. So in this case, message chop friend shows the rest of the string. And we can check if a string contains another string using the include method. It'll return true if the string exists and false if it doesn't. Message include best returns true. So we can get the index of a character or the index of the first character of a substring using the index method. And it returns if the character or substring does not exist. Message index your returns 8, which is the index of the y character. Now we can check to see if a string starts with a character or a substring using the start with method. Message start with Ruby returns false because it is case sensitive. Message start with Ruby returns true. Okay, so we can use end with as our method to check if a string ends with the given substring. And it works exactly like start with. Message end with friend returns true. We can use the delete suffix and delete prefix to get the rest of the string removing the suffix or prefix. Message delete suffix friend removes the suffix. Message delete prefix Ruby removes the prefix. Now we can also convert an array to a string using the join method. A, B, C as an array join returns a string. And we can pass an argument to the join method as a separator. Join with a dash symbol shows the result. We can build up a big string from the smaller strings by appending characters to the existing string. The append symbol is 2 less than characters. So message is an empty string. Message append, I like. Message append cats. And now message is I like cats. We can also replace text inside a string using the gsub method. So why don't we replace cats with dogs in the message variable? Message gsub cats dogs returns I like dogs. So open up the terminal and type IRB to start up an interactive Ruby shell. Now, if we want to convert like 5 in quotes into the integer 5, we can use the toI method. So assign it to a variable, a, and then let's check its type. A class shows integer. Now, if we try to convert strings that contain no numbers, we will get 0. A to I shows 0. We can convert all other types to strings using the toS method. 5 to S shows 5 as a string. To check to see if a string is empty, we can use the empty method. A is the empty string variable. A empty returns true. Now, sometimes we may need to format our strings by adding or removing characters, white spaces. So we can use the center method to surround a string with spaces. Ruby center 15 shows the strings with spaces. We can specify a string as the second argument if we want to use a different character. Ruby center 15 dash shows the string with dashes. We can also use ljust or rightjust as our methods to add spaces or characters to the left or the right side of a string. Ruby ljust 15 shows the string with spaces. Ruby rjust 15 shows the string with spaces. And we can also specify a string as the second argument if we want to use a different character. So Ruby rjust 15 hash shows the string with hash symbols. We can use the rstrip method to remove leading spaces from a string. Ruby with leading spaces, rstrip removes the leading spaces. So we can use lstrip as our method to remove trailing spaces from a string. Ruby with trailing spaces, lstrip removes the trailing spaces. We can also use the strip method to remove both leading and trailing spaces. Ruby with spaces, strip removes the spaces. Now let's use some single quotes for creating strings. Message equals I don't like cats. And as you noticed, Interpreter does not recognize the end of the string, and we get a syntax error. So we need to escape the apostrophe character with a backslash. Message equals I don't like cats with a backslash. And there you see no error. We can create multi-line strings in two different ways. The first one is here docs, message equals open here docs with a name such as string, first line, second line, close here doc, string, shows the result includes new line characters. And then the other one is using special characters. Message equals %Q, open parenthesis, first line, second line, close parenthesis, shows the result includes new line characters. We can create strings inside a pair matching arbitrary delimiter characters, such as parenthesis, curly braces, preceded by a % character, capital Q. Q and X have special meanings. Ruby is your best friend within special characters, returns a string. So this creates ls command and returns the execution result, which lists files and directories in the current working directory. It's a backtick command output. We can find out the current encoding for a string using the encoding method. Message encoding returns the current encoding. And sometimes we may encounter encoding problems while reading a file or downloading data from a website. We can often fix that problem by enforcing the coding. So, message, force, encoding, UTF-8. So, UTF-8 is a complex encoding which allows us to represent characters from different languages. So now that we got all that set up, we are going to make another project. In this project, we will use string methods so that we can better understand them. Let's say that we want to generate email addresses for the companies that we work with. We are offering a service to generate email addresses. So let's start encoding. Open up your Aptana Studio or any of your favorite development editors. And let's create a Ruby project. Project name is Email Generator. Then create a file. File name is main.rb. Now, let's think about how do we create email addresses. Generally, people choose email addresses as a combination of their first name and last name, so let's just keep it simple and do it the same way. So we'll need to know, for instance, what the first name and the last name is, also what the company's name is. So we're going to need to take them from the user. And how do we do that? Right, using the gets function. Print name. Name equals gets chomp. Remove the new line character. Print last name. Last name equals gets chomp. Print company. Company equals gets chomp. And let's print the name of the program. Put company email generator. Now we can simply create email addresses concatenating the variables. So email equals name plus last name plus company and appropriate symbols. So yeah, we can generate email like that. But concatenating the strings with the plus symbol is not a very efficient way, is it? We can concatenate those on the same object by appending. So if we create an empty variable, email, append symbol, name, email, append symbol, dot, email, append symbol, last name, email, append symbol, at, email, append symbol, company, email, append symbol, .com. And of course they should be in lowercase. Puts, email, save it and run. And entering the inputs, John Doe example. Yeah, see, that looks good. Now, what about double names or last names? So let's run it again. Entering John Edward Doe example, and email is not a valid address. There's a space. So we should be able to handle this situation. So we can use the split method. Remember, the split method uses spaces by default, and we can join the result with dot. So Ruby is a perfect object-oriented language. Everything is an object. String methods returns objects. So that means we can apply other methods by method chaining. The split method returns an array object. Then we can apply the join method. So let's start out that by applying the split and the join methods to the name and the last name. And yeah, see, so now we can handle multiple name and last name situations. Let's save it and run it again. Entering John Edward Doe example. And there you have it. It is a valid email address. Okay, so everything looks pretty good, but if the company name is more than one word, what happens then? Let's run it again, find out. Entering John Edward Doe example games. And yeah, the email address is invalid. So how do we fix that? We can't do what we did for the name and the last name. Dot, it's not going to be valid after the at symbol for email addresses. So we need to remove spaces. We can remove spaces with the split and join methods. But if we do not specify any parameter to the join method, it will simply concatenate. Applying the split and join methods to company. Now, save it and run it again. And entering John Doe example games. And yeah, sure enough, it is a valid email address. Yeah, so in this project, we created a simple company email generator, and we used some string methods. And I'll bet you that you can improve on the project using email address rules. You with me? So conditionals are indispensable pretty much in almost every programming language. We almost always need the ability to check conditions and then change the behavior of the program accordingly, all right? Decision structures will evaluate expressions which produce true or false as the outcome. And you're going to need to determine which statement to execute if an expression outcome is true or false otherwise. So this diagram is the general form of a typical decision-making structure. Ruby will assume any non-zero and non-nil values as true, and if it is either 0 or nil, then it is assumed as a false value, right? So the diagram shows if some condition occurs, check the condition. If the condition is true, execute the conditional code. And if the condition is false, pass conditional block and continue. All right? So let's go ahead and do up some examples to understand those conditionals really clearly. So open up your Aptana Studio or any of your favorite development editors. By now it better be Aptana, but I'm just saying. And we're going to want to write in a file, not an interactive window this time. So let's create a Ruby project. And the project name is Examples. Now, create a file. And the file name is conditionals.rb. All right, so now we can begin to start the code. Let's say that we have two variables. A is 5 and B is 4. Conditionals evaluate Boolean expressions. So Ruby has if, else if, and else as the keywords to write conditionals. The Boolean expression after if is called the condition. So if the condition is true, then the intended statement gets executed. If not, nothing happens. So if A is greater than B, puts A is greater than B. First if statement is ready. So let's save it and run the script. Run script shows A is greater than B. Now, if you notice, the editor made an indentation before the print statement. We can actually intentionally make indents with the tab key. Ruby's default indent block size equals the tab key. All right, so let's continue. A second form of the if statement is alternative execution. So there are two possibilities, and the condition determines which one gets executed. If A less than B, else puts A is greater than B. Save it and run it. It shows A is greater than B, else statement is executed. Now, sometimes there are more than two possibilities. This form of the if statements is called chained conditionals. If A less than or equal to B, then puts A less than or equal to B. The syntax: the variable in hash and curly braces to get the value of the variable in the string. Else if A greater than or equal to B, then puts A greater than or equal to B. Run it, and it shows 5 greater than or equal to 4, the second condition. So if we have one more condition, else if A is not equal to B, then puts A not equal to B. So let's run it. Shows the same result, but third if condition is also true, because chained if conditionals are iterative and then evaluated as one big statement. If one condition has occurred, other conditionals will not be executed. So if you want to check this condition prior to the others, you've got to place it before. So let's cut and paste and run. Now it shows the expected result, 5 not equal to 4. So we can also nest these conditionals. So let's select the last if condition block, press the tab key. Now, last block in the second if block, we do not need the else if keyword. We need the if keyword. So make the required indent for a put statement, and now it's ready. So run, and it shows 5 not equal to 4 and 5 greater than or equal to 4, right? So it means that the last if condition will be executed only if the second if statement is true. Cool? If A is greater than 10, then puts A greater than 10. Else if B less than 2 puts B less than 2. Else puts else statement. Run, and it shows else statement because A, 5 is less than 10. First condition is false. B, 4 is greater than 2. Second condition is also false. So it executes the else statement. We can use logical operators in conditionals. If A is greater than B and B is greater than 0, then puts both conditions are true. Run, and it shows both conditions are true. So 5 is greater than 4 and 4 is greater than 0. So we get true and true with logical and operator. It results in true. If A is less than B or B is greater than 0, then puts at least one of the conditions are true. Run, and it shows at least one of the conditions are true. So then, 5 is less than 4. Condition is false. 4 is greater than 0. Condition is true. False or true results with or logical operator, and it gives true. Now, sometimes we may have only one statement to execute, so we can then put it on the same line as the if statement. How do you do that? Puts A is greater than B, space. If A is greater than B, run, and it shows 5 greater than 4. So it's kind of a shorthand again. Now, in Ruby, we can make variable assignments with if statements. Let's try that with message equals if A is greater than B, then A greater than B, else if A is less than B, then A less than B, else, then A equal to B, end. Puts message. Now run it, and it'll show A greater than B. The first block is executed. So sure enough, in this lecture, we did a bunch of examples, and hopefully enough for you to understand how these if statements influence the results. To make it crystal clear, you should really do some more exercises until it just becomes second nature. So open up your Aptana Studio or any of your favorite development editors. Now, we have created a Ruby project and run a Ruby script, conditionals.rb, in the previous lecture. So let's say we have a check mechanism for our website. Okay, so if it is not online, then we will show the maintenance page. So that means we have a variable is online equals true. If not operator is online, then puts maintenance end of if statement. So in most programming languages, we check false expressions just like that. However, Ruby has a really nice unless operator, so that provides a much more readable code. So let's change our online status to false. Then use unless as our modifier. So now let's save it and run it and see how that shows maintenance. And we can also do variable assignments with unless statements. So page equals unless is online, then maintenance, else, then homepage, end of statement. Puts page, run the script, and it shows the result. Ruby also has a nice option for a quick if-else statements. These types of statements are called ternary statements. I'll define that in an example. Okay, so page equals is online as a Boolean expression, question mark, home page as a true condition, if statement, colon, maintenance as else statement. Puts, page, run the script, and it shows the result. So the ternary operator is a combination of question mark and colon symbols. Okay, now sometimes we may want to implement in one line so that we can put it on the same line as an unless statement. So puts maintenance unless is online, run, and it shows maintenance. And again, that's kind of a shorthand for the unless statement. Now we can do it in another way as well, as just a one-liner. Unless is online, then puts maintenance end. Run the script and look at the result. We can implement an else statement in this one-liner as well. Else puts homepage end. Run the script and look at that result. We can apply the same syntax for if statements. If is online, then puts homepage end. Run the script and look at the result. So go ahead and open up your Aptana Studio or any of your favorite development editors. Now we've created a Ruby project and a Ruby script, conditionals.rb in the previous lecture. Ruby has another conditional flow structure, and that's called case statement. A case statement is similar in functionality to an if statement with a slightly different interface. So if we need multiple if, else if, or else blocks, we should use case statements. I'll give you an example. Let's say that we have a number and we need to check the value. So number equals 1, case, number, when 0, then puts number is 0. When 1, then puts number is 1. Else, then puts number is neither 0 nor 1. End of case statement. So save that, and let's run the script. And it shows number is 1. So we can remove the variable from a case statement and then add two when statements. So save it and run the script, and it shows the same result. We can also make variable assignments with case statements. Result equals case statement, remove puts methods. Puts, result. Save it and run the script, and it shows you the result. Now we can also use shorthand case statements. Result equals case. When number is greater than 0, then positive. When number is less than 0, then negative. Else, then 0. End. Puts, result. So save that and run the script, and it shows positive. We can write when statements as a one-liner using the then keyword. So we can use ranges in case statements. So let's say that we want to decide cloth sizes according to waist measurements. Okay, so waist equals 38. Case, waist, when between 29 and 31, then put small. When between 32 and 34, then put medium. When between 36 and 38, then puts large. End of case statement. Save it and run that script. Now it shows large because the variable value is in the last range. Very good. Alrighty then, so you're ready for another project, aren't you? Yes, so let's make a project using the conditionals that we've just learned. So let's say that we are implementing part of an exam grading system, and we'll need to convert exam results into a letter grading system. So let's get to coding. Open up your Aptana Studio or any of your favorite development editors. So let's create a Ruby project. The project name is letter grading. Then create a file. File name is main.rb. Now, first of all, we'll need to know a particular exam point. And how do we do that? Yeah, we'll get it from the user. Okay, so print, enter grade point. Grade equals gets chomp. Gets, the function takes the user input with a new line character. So we need to use the chomp method to remove it, remember? Now the gets function returns everything as a string by default. So we need to also convert that to an integer. So then, using toI as our method, and yeah, so now we can use decision statements to return a correct letter grade. So we'll use common academic grading intervals just, for this particular project, but it's going to differ in a variety of countries. But just follow along and you'll get the idea. We can use case when statements and return it into a variable. Result equals case grade when 90 to 100 with inclusive range, then letter grade A. When 80 to 90 with exclusive range, then letter grade B. When 70 to 80 with exclusive range, then letter grade C. When 60 to 70, then letter grade D. When 50 to 60, then letter grade E. And when 0 to 50, then letter grade F. End. Puts. Result. Yeah, now it seems to be completed, so let's save it and run. And entering 89, and sure enough, the letter grade is B. So now let's run it again, but this time let's enter in a higher number, 120, and look at that, the result is nothing. So points should not be higher than 100. So in that case, we can use an else statement to handle this situation. Else, invalid input. Let's run it again. And entering 120, and it shows invalid input. So it's a simple project, yeah, but you can always improve on it by adding extra conditionals, such as a negative check, etc., etc. Now, in general, statements are executed sequentially. The first one is executed first, the second is executed second, and so on. So there may be a situation when you need to execute a code block more than a certain amount of times, certainly more than once, right? So we can execute one statement or a group of statements multiple times by using loops. So this diagram is the general form of a loop statement. Ruby provides several different types of loops to handle looping requirements. The most common forms are these following types. While loops. A while loop repeats a statement or a group of statements for a while, given a condition is true. It checks the condition before executing the loop block. For loop. A for loop executes a sequence of statements multiple times and abbreviates the code that manages the loop variable. Let's see how it works. So first, let's have a look at how while loops work. Open up your Aptana Studio, or any of your favorite development editors. Then, create a file. File name is loops.rb. Okay, so let's start. Let's say we want to print numbers from 0 to 5. We'll need a loop variable, I, and a value of variable is 0. Now, while, keyword, and the condition I is less than 5. And now writing the body of the loop. Puts, infinite loop. Save it and run the script. And that loop will work forever. So let's terminate the program by clicking on the red button. So now you might be able to see that we need to increment the loop variable value. If not, the loop will work forever. I plus equals 1. So now let's run it again. And it's showing numbers starting from 0 to 4. 5 is not included. Why? Because we use the less than operator. So go ahead and delete this example, and let's do another example. We can implement while loops as a one-liner. Put code block, increment the loop variable while I is less than 4, and loop variable is -1. The increment operation works first, so we need to set the loop variable -1. So let's save it and run the script, and there's your result. So another type of loop is until loops. The until loop works the same as the while loop. It just checks false conditions. So I equals 0 until I is greater than 5. Puts I plus equals 1. End of loop. Save it and run the script, and there's your result. We can also implement until loops as a one-liner. The loop variable I is -1, puts code block, increment the loop variable until I is greater than 4. The increment operation works first, so we'll need to set the loop variable to -1. Save it and run the script. Have a look at the result. So let's have a look at how for loops work. Let's start her up. Let's say that we want to print a range of numbers starting from 1 to 5. Now we can use the for keyword. For I in 1 to 5 as range. The in keyword is a membership operator. Then put I, and save it and run it, and see how it shows each number. Do another example. So let's say that we have an array of letters, and we want to print each of them. So let's delete the range. A, B, C in brackets. We're going to focus on the array data type in detail in future lectures. But right now, we're just creating a simple one. Okay, so let's print each letter in the array. Save it and run the script, and it prints each letter in the array. Iterators are methods that loop over a given set of data and allow you to operate on each element in the collection. So why don't we have a look at that in an example? So a range, 1 to 5. Each, open curly brace, iterator variable, I, in pipes, then put I, close curly brace. Save it and run the script. And it shows each number in the range. So yeah, there's a bunch of things here that need a bit of an explanation. Each is the method that works on collections such as arrays and hashes. Then it begins executing the code within the block. The block's starting and ending points are defined by curly braces. So each time we iterate over the array, we need to assign elements of array to a variable. The definition of a variable is placed between two pipes. Then after that, we can implement the logic, and this time around, it was just simply printing the element of the array. Now, if you have put 2 and 2 together so far, yeah, these types of codes are called blocks. So we can use curly braces when everything can be contained in one line. If we need to perform multi-line operations, we can use do and end as our keywords. So, why don't we do some examples? In fact, let's just do the same example with do and end as our keywords, and then you'll see what I mean. 1 to 5 as our range. Each do I in between pipes as a block variable. Puts I. Save it and run the script, and that shows each number in the range. So let's have a look now at how do-while loops work. A do-while loop is similar to the way that while loops work. The only difference is that the code within the loop gets executed at least one time, because the conditional check works after the code within the loop. So let's use the begin and end keywords besides our loop modifiers. I'll show you in an example. I equals 0, begin, put I plus equals 1, end, while I is less than 5. Save it and run the script. Shows each number 0 to 5. We can also use until loops. So why don't we just change while to until, and also condition. Save it and run the script, and it shows the same result. So when using loops, sometimes we may need to terminate current iterations or loops and do other executions in, well, certain conditions. In this situation, we can use break and next as our statements to alter the flow of a normal loop. So let me show you how to do that. So let's say that we want to print numbers starting from 0 to 5, but when it reaches 3, break that loop. So we'll create first a loop variable, I is 0, while I is less than 5, puts I, and increment the loop variable. Save and run. Prints numbers from 0 to 5. So now let's add a break statement. If I is equal to 3, then break. Save it and run the script. Show number 0 to 3. So yeah, when loop variable equals 3, it executes a break statement and then exits from the loop. So now let's say that we want to print numbers starting from 0 to 5 except 3. So I equals 0, the loop variable, while I is less than 5, increment the loop variable, puts I, and before the print statement, if I is equal to 3, then next. Save it and run the script, and it shows each number except for 3. Now, sometimes we may need to run an always condition on some block of code until a certain condition occurs. So these types of loops are called infinite loops. The condition is always true. We can only exit with break statements. So in other words, we can use the loop keyword to create infinite loops. Also, other loop types can be used for infinite loops. Loop, do, put, infinite loop, save it and run, and see how it shows the put statement forever. Now we can control these types of loops with conditions and break statements. So let's create a program that gets a number from the user and then checks it to see if it's greater than 100. If so, it breaks the loop. If not, it continues to ask. So enter a number. Number equals gets chomp 2i. Let's convert to integer. If number is greater than 100, breaking the loop. Break. Save it and run the script. So entering 5 continues to ask a number. Entering 50 asks again. Entering 120. And yeah, there you see that the condition is executed and the program is terminated. So now we're going to do a kind of project that we're going to employ a mathematical concept. We're going to learn it if you don't know it already. It's called the Fibonacci series, and we will learn how to implement it in Ruby programming to see just exactly how important this is. So let's start coding. Open up your Aptana Studio or any of your favorite development editors, and let's create a Ruby project. Project name this time is Fibonacci. Okay, not the greatest of accents, but the spelling's correct. Then create a file name. File name is main.rb. Now, the Fibonacci series is a series of numbers that each number is the sum of the two preceding numbers. So simply starting with 0 and the next number is 1, add the preceding number to the current number results in 1. Add again the preceding number 1 and the current number 1, the result is 2. Add 1 to 2, results in 3. Add 2 to 3, results 5. Add 3 to 5, result is 8. Add 5 to 8, results in 13. Add 8 to 13, the result's 21. Add 13 to 21, the result is 34. Add 21 to 34, the result is 55. And it goes on like that. But anything higher than that, and I'm going to need a computer. As a matter of fact, it really does some heavy calculation, you can imagine, on even higher and higher numbers. So now we want to show each Fibonacci number according to user input. Now, the highest Fibonacci number will be less than or equal to the user input. So we'll need to take the input from the user. So inform the user. Print. Enter a number. Number equals gets. Remove the new line character. Now, it should be an integer, so convert with 2i as our method. Now we need to indicate a starting number. So Fibonacci equals 1. And also a preceding number is required. So Fibonacci prev equals 0. Now, we can use a loop to calculate each number. While Fibonacci less than or equal number, then puts Fibonacci. Now we should add previous to our current number and assign it as current. You follow? So Fibonacci equals Fibonacci plus Fibonacci prev, but the previous number should be assigned with the current number's old value, right? So Fibonacci prev equals Fibonacci. But see how the Fibonacci is changed? How can we do this? We can use a temp variable to keep the old value of Fibonacci. So temp equals Fibonacci. Then assigning Fibonacci prev equals temp. Right, now that looks good. So save it and run it. Entering 100. Look at that, it shows each Fibonacci number. Good job. So you see, our program works really good, but I think that we can do it even in a better way. So Ruby comes in handy. It has a great feature, and that's called parallel assignment. We've already learned it in previous lectures, if you recall. So let's use parallel assignment instead of using our temp variable. So yeah, we're going to change the code. Fibonacci prev Fibonacci equals Fibonacci plus Fibonacci prev. And yes, the assignments will be done in order. So let's save it and run it. Entering 100, and see how that shows the same result. Now, a method is a block of related statements in order to perform a specific task, right? So thanks to methods, we can break our programs into smaller and modular chunks, so codes can be more organized and certainly manageable. It also avoids repetition, and then that way the codes become reusable. So we've already used methods in our examples before, but in Ruby there are two types of methods: Ruby built-in methods and user-defined methods. Now we used built-in methods such as puts and print, as well as gets. So when we want to call a method, a call statement will be a method name and parameters in parentheses. So let's see the print method usage. Print Ruby in parentheses. The print method prints parameters that is whatever's provided by the user, right? Parentheses are optional in Ruby, so we can also call without parentheses. Print Ruby. So earlier we've learned how to give names to the variables. We can create variables that their names can be the same as the method's names. And it does not violate variable naming rules, so we can create a print variable and its value is this is a variable. So let's call the print method again. And sure enough, it works. But what about printing the variable? Print shows the value of the variable. All right, so now that we know how to call methods, what you have to understand is it's better to not give names to the variables the same name as the methods to avoid ambiguous situations and to have a much more readable code. So in that previous lecture, we learned that there are two different methods in Ruby. We used built-in methods, and now let's see how to create methods. So open up your Aptana Studio or any of your variety of favorite development editors, and let's create a Ruby project. Project name is Examples. Then create a file. File name is methods.rb. So when defining methods, we use the def keyword, the method name, and the parameters in parentheses. So this line is the method header. And let's do a simple one. So def hello as method name, then print hello. And sure enough, we can define methods without parentheses if no parameter is specified. So let's call it hello and parenthesis. Save it and run the script, and it shows hello. So we can also call it without parentheses if the method takes parameters. So let's say that it takes name as the parameter. Editing, put statement. Now we need to pass a name as a parameter. Hello, Jack. Save it and a run, and it shows, hello, Jack. So let's call it without parentheses. Save it and run, and it shows hello, Jack. So let's call one more with a different parameter. Hello, Jane. Okay, so we can call it as much as we want. The methods avoid repeating the code blocks and then preventing reusing the codes. So this method really only has one functionality, and that's to print some value so that it returns nil or nothing. We can optionally write a return statement. So let's return put statement as a message. Now, the hello method returns a value. So let's print a returning value. Run, and it shows a result. Okay, so let's remove the variable and then directly return the message. Run, and it shows a result. In Ruby, the last statement is always the returning value, so you do not have to use the return keyword. But it can make your code a lot clearer. So let's do another example. This time I want the method to return a Boolean value, true or false. So let's say that we want to check a number just to see if it's negative. Def is negative num. Then if num is less than 0, return true. Else, return false. Let's call the method puts is negative 5. Run, and it shows false. So how about another example? Let's say I want to get the square of any given number. Defining square method. And we can do the calculation two different ways. Multiplying the number by itself or the exponent operator. So let's say that I want to do it with the exponent operation. So return num, exponent sign, 2. Okay, so let's call the square method. Save it and run. And it shows 81. So just like the methods, Ruby has a concept called blocks. A block consists of chunks of code. We can assign a name to a block, and the code in the block is always enclosed within curly braces. So block is always invoked from a method. Methods and blocks should be the same. So let's define a method. Def test. We can invoke a block by using the yield statement. So let's call the block test. Curly braces, puts a block named test. Save it and run it. And it shows a block named test. Now we can invoke the block multiple times, change the method statements, puts, I'm in the method, yield, invoke the block, puts, I'm in the method, yield, invoke the block, test, puts, I'm in the block, run, and it shows a result. Each yield statement invokes the block. Now we can also pass parameters to a block with a yield statement. Yield. This is a block parameter. Yield 1. We can accept parameters as variables within pipes. So run it, and it shows the result for each yield. Now, if we want to pass more than one parameter to a block, we can use a comma, change yield statement, and change the block. Run, and it shows a result. Now, Ruby has some custom blocks. We can declare blocks of code to be run as the file is being loaded using the begin block statements, and after the program is finished executing using the end block statements. And as you might be able to guess, they should be in uppercase. Begin, puts, begin block, end, puts, end block, puts, main program. Save it and run it, and it shows the begin block first, then the main program, and the end block. We can define multiple begin and end blocks. Begin blocks are executed in order that they are encountered. The end blocks are executed in reverse order. So we can call methods with a variable number of arguments. Let's see it in some detailed examples. So first, let's create a method. This method's name is printer, and it prints the val parameter. So let's call the printer method, run it, and we get a missing argument error. The error shows a required number of argument, which is 1. Calling it up again with test argument, run it, and it shows test. Okay, so let's make another example. Define a person method, and it'll take 2 parameters, name and age. Prints name and age. By the way, to avoid misunderstanding, a parameter is a variable in the method definition. So when a method is called, the arguments are the data you pass into the method's parameters. The parameter is variable in the declaration of the method. Argument is the actual value of this variable that gets passed to the method. So let's call the method with Jane and 23 as arguments. Save it and run, and shows a result. So let's change the arguments. The first argument is age, 34. Second one is name, Jack. Run it, and it shows a result. But it does not work as expected, does it? Because parameters are positional. So we should pass arguments in the correct order. So let's say that we can set a default value to a parameter. Let's change the age parameter with a default argument. Now we can call the method with one argument. Run it, and it shows a result. Age is 30 as the default argument. So let's pass age argument as 32. Run it, and it shows age is 32. So let's change the name parameter with a default argument, Jane. Now we can call the method without any argument. Run it, and it shows default values. So what if we pass arguments with keywords? Keyword arguments are alternatives to positional arguments. The colon symbol is used for defining keyword arguments. We can call the method without any argument. So run it, and it shows the same. And call with new keyword arguments. Run it, and it shows a result. Now, if we change the order of arguments with the keywords, run it, and it shows the same result. So using keywords provides us flexibility at passing parameters without having to think about the order. So you ready for another example? Sometimes we may need to execute a method for more arguments than provided while defining the method. These arguments are called variable length arguments, and they are not named in the method definition. So let's see an example of that. Let's say that we want to print names, but we don't know how many names are going to be passed. So create a hello method, and it takes names as a parameter. Now, to indicate that the names parameter will take variable length arguments, we use the asterisk before the parameter names. Name, each, open a block, name as block variable, puts name. Now let's call the function. Hello, Jane. We can call without parentheses. Run it, and it shows Jane. So let's add more arguments. Hello, Jane, Jack, Bruce. Run it, and it shows a result. And we can use blocks as arguments for methods. Def, test, ampersand, block. The block argument is indicated by ampersand symbol, and it must come last. Block, call, and yeah, we can execute the block using call method. It works the same as yield. So let's call the method with a block. Test puts a block in a block. Run, and there's your result. Now, the lambda function, or anonymous function, is a function that is defined without a name. So we use the def keyword to define methods. However, to define anonymous functions, we use the lambda keyword. In Ruby, the lambda function syntaxes change according to one-line or multi-line usage. For one-liner expression, we can use lambda keyword in statements in a block. Lambda in a block, x within pipes, x multiplied by x, puts the lambda function. So save it and run it, and it shows that the lambda function is just a proc object instance. Proc objects are blocks of code that have been bound to a set of local variables. Once bound, the code may be called in different contexts and still access those variables. So we can execute the proc object by running the call method in this example. call 8. The arguments of the call method will be passed to the Lambda. Run it, and it shows 64. We can directly print the result in the Lambda function. Run, and it shows 64. Another way to create a Lambda function is the arrow syntax. It is a proc instance as well, and we can execute it with a call method. So call 8, run it, and it shows the same result. We can assign the arrow function to a variable. Square equals the arrow function. Then we can invoke it using the variable. Puts square call 8. Run it, and there's your result. So this type of usage is for one-liner solutions for the Lambda function. Now we can also create multi-line Lambda functions with Lambda and do as our keywords. So Lambda, do, x within pipes as Lambda variable, x multiplied by x. We can assign it to a variable, square, puts square call 8, run it, and it shows 64. We can also use Lambda functions as an argument of a method. Def test function argument function call argument end of method. Puts test square 8, save it and run it, and it shows a result of 64. So in Ruby, there are 5 different types of variables. Now, let's talk about 2 of them, the local and global variables specifically. So let's create a Ruby file in our existing project examples. File name is scopes.rb. In Ruby, each type of variable is accessible according to a variable's scope. A variable's scope is defined by where the variable is initialized or created. Variable scope is defined by a block. As you know, blocks are code statements, usually delimited by curly braces or do end keywords. Right, so let's do an exercise. Ruby has a built-in method called times, which executes code blocks on given times. So 3 times do end, it means the inner code block will be executed 3 times, right? So A equals 2. It's simply initializing a variable. Outside of block, puts A, save it and run, and it shows an undefined local variable error because A is not accessible when it's outside of the block. It is a local variable for times code block. But what if we initialize it before the times method? A equals 5. Save it and run, and it shows the new value of the variable. Now what about variables within methods? A equals 1. Create a method named test. Def test. A equals 5. Puts A is a local variable. Call the method test. Run it, and it shows the print statement. Is the value of the variable changed? Put A, run it, and it shows 1. So variable's value is not changed because the variable A in the method is not the same as the outer variable A. They are different variables in different scopes. Okay, so another type of variable is the global variable. Global variables begin with the $sign. So create a global variable, A equals 1. As you noticed, our editor, Aptana, shows global variables highlighted in red. So put A is a global variable. Create method def test. Puts A equals global variable A in interpolation. So let's call the method test. Save it and run it, and it shows a global variable. So sure enough, we can also access global variables in other scopes. So why don't we try to change the value of a global variable? A equals 5. Now let's check the variable if it's changed after calling the method. Puts A, save it and run it, and it shows a new value of the global variable. And so there you have it. We can indeed update global variables. So in Ruby, a method can call other methods. It's even possible for the method to call itself. These types of methods are called recursive methods. So let's see how they work. So let's say that we want to sum numbers starting from any number to 0. Yeah, it's possible to write a loop and sum all numbers, but this time we want to use recursion. So for example, sum starting from 5 to 0. Define a method, calculate, and it takes a number variable as a starting point. If number equals 0, return 0, else return number plus, call the method, calculate, with decreasing numbers by 1. And that's all. So the if condition is our base condition. Recursion ends when the number reduces to 0. Every recursive method must have a base condition. Base conditions will stop the recursion, or else the method really will call itself infinitely. So let's call the method. It will return a number, so calling it in the puts method. Okay, run, and it shows 15. It's true. So try with number 10, run, and it shows 55. So we can change the if-else conditionals with simpler statements. We can use a one-liner if statement. Return 0 if number 0. The built-in method 0 checks the number to see if it is 0. Ruby uses the last statement as the returning value, so we can just use it like that. And yeah, see, so if you run it, it shows 55. And yeah, recursive methods have some advantages as well as some disadvantages. Recursive methods make the code look clean and elegant. Using recursion, complex problems can be broken down into simple tasks. And it's also easier than iteration to generate sequences. Of course, these are advantages. Now, some recursions need complex logic, so it could be hard to follow through. Also, debugging is pretty hard in recursive methods. Recursive methods are also inefficient. So it means that they will take up a lot of memory as well as your time. And that's only some of the disadvantages. So here we are at a new project. So in this project, we will make a calculator, but it's going to be a simple one. So let's start coding. Open your Aptana Studio, or whatever your favorite development editor is at this time. Aptana, right? So create a Ruby project. The project name is Calculator. Then create a file. File name is main.rb. So we're creating a calculator, right? So our calculator is going to be doing some basic arithmetic: addition, subtraction, division, multiplication. So first we've got to create a menu. Puts calculator. Puts A for add. Puts B for subtract. Puts C for multiply. Puts D for divide. Then print, select, and choices. Choice equals gets chomp to remove the new line character, and add another option. So puts Q for quit, and so we want to execute the program in an infinite loop until the user wants to exit. So let's take the menu block in a loop. While choice is not equal to Q. Now let's run the script to check menu usage. And sure enough, that worked great. So now we need to take inputs and make calculations according to choice. We will do addition, subtraction, division, and multiplication operations, like I mentioned before. So let's create these functions. The operations are just one-line statements, so we can use Lambda functions. Add equals Lambda do num1 and num2 as block variables, num1 plus num2. Other functions are similar, so you can just copy and paste that. Changing this to subtract, changing the operator, change to multiply, and changing the operator, change to divide, and changing the operator. And so our functions look ready. Now, earlier lectures, we've talked about, and hopefully learned, that we can use these functions as method arguments. So let's create a manager for functions. Def manager function as parameter. So now we're ready to get inputs from the user. Print number 1, num1 equals gets chomp 2i. Remember, that converts to integer. Print number 2 num2 equals gets chomp 2i to convert to the integer, and our functions return a value, so result equals function. we can use the call method to execute a given function. Call num1 and num2 as function parameters. Now we can print the result. Puts result equals result in interpolation, and using center as the method to draw attention. Okay, so our manager function looks ready, and it's time to complete the menu block. So we can use a case when statement. Case, choice. When choice is A, then manager, add. When choice is B, then manager, subtract. When choice is C, then manager, multiply. When choice is D, then manager, divide. Yeah, it seems to be complicated, but first, let's save it and run the script. And choosing A, number 1 is 10, number 2 is 20, and the result is 30. So yeah, let's do another one. Choosing C, number 1 is 4, number 2 is 200, and the result is 800. See, so that works great. So we'll terminate the program with Q. So this Ruby language has a special feature called modules. A module is a structure for grouping constants, methods, as well as classes. Modules are used to break down large programs into small, manageable, and organized files. So why don't we see how to do that? So we have a Ruby project. Project name is examples. Then we'll create a file. The file name is test_module.rb. So we'll use the module identifier for creating modules. Module A, and let's say that we have a constant, message. Constants, by the way, should start with an initial uppercase letter. We can define them in uppercase. Message. This is a module constant. We can define methods in modules. So let's say that we have a square method which takes a number and returns the square of it. Def, module A, square, number, multiply by number. So basically, the definition of a module method means that it consists of a module name and a method name. And sure, our simple module looks good, so why don't we try and import it and then use it in another Ruby script. So let's create a file, and the file name is main.rb. So when we try to import modules into other files, we'll have two options. The first one is importing the module with the require keyword. So let's use that one. Require test module.rb. So let's save that and run it. And we get an error, a load error, that Ruby cannot load the file. So what this means is that Ruby looks for certain directories to run scripts. These directories are stored in a global variable, load path in uppercase, and it starts with the $sign. Now, as you know, global variables start with the $sign as well. So let's see what the load path has. We can print it out with puts, and it's an array of directories. So save it and run, and it shows us all directories. And yeah, so we can go ahead and append our current working directory to load the path so that Ruby can load our module file. Now we can use two less than symbols to append a value to an array. We'll see the details of an array structure in the following lectures, but right now we're just going to use it. Load path, two less than symbols, a dot. A dot refers to our current directory. We can also use a full path. Now let's run it again, and the error is gone, and our current working directory reference, a dot, is in the load path. So now we can use our module in this file. And one more thing, we don't necessarily have to write the extension of the file. It's going to work either way. So let's remove the extension, run it again. No load error. And yeah, so let's go ahead and print the module constant, puts module A, 2, message. So yeah, we use the 2 colons to get constants. Save it and run the script, and it shows the value of the constant. So let's call the square method. And it's going to return a number. So puts module A dot square 5. Save it and run, and it shows the result, 25. Now another way of using the require keyword is using a relative path. When we use this, appending the current working directory to the load path is not necessary. Require dot / test module, save and run, and it shows the same result. So yeah, we could import the module and run the methods of the module. And yet another way of importing the module is using the require relative keyword. Require relative, test module, save it and run it, and it shows the same result. Now, a gem is a bundle of software to be installed. There are many built-in gems that come with a Ruby installation, but we need to make some custom gems for custom executions. We can find and install the software developed and shared by the Ruby community at Ruby Games. Ruby Gem is a sophisticated package manager for the Ruby programming language. We have installed Ruby by using the RBEnv tool, so the gem tool is already installed. We can also install the gem tool following these instructions. So let's learn right now about installing gems. Open up your terminal or command line. Ruby gem installations are managed by the tool Gem. Gem help shows all the available commands that you can execute. So we can use the install parameter for installing gems, the uninstall parameter for uninstalling gems. But first, let's check the version. Gem version shows us the version. And we can use the gem list command to show all the installed gems. Okay, so let's install a gem. Let's say that we need a math-related gem. And yeah, there are lots of gems regarding math. Now, these are all community gems, so some of them may be out of date or they're not being developed actively. So you might as well check the latest release dates as well as the documentation. So let's have a look at this one. Yeah, so we can use this package. So copy the installation command, and let's open the GitHub page. and it shows the documentation. And now let's go back to the terminal. Paste the command and enter. And yeah, it's successfully installed. So let's check again with the list command. And we can use the up and down arrow keys to get a list of commands that have run before. And sure enough, it's in the list. So let's open Interactive Ruby Shell, IRB, and importing the module require business time. And yes, it returns true. We could import it. So let's copy some examples from the documentation. Just paste it and enter. And yeah, it shows that the date is 1 business hour from now. So let's copy another example. Paste it and enter. And yes, it shows the date that is 8 business days ago. So let's quit from IRB. So yeah, we can install gems according to our needs. We can also uninstall gems if we don't need them anymore. Gem uninstall, gem name, and we've removed the gem successfully. So let's make sure of that. And it doesn't seem to be in the repository any longer. Now, we've talked about arrays earlier. Just to clarify, an array is an ordered and integer indexed list of elements that can be of any type. So each element in an array is referred by an index. So let's see how to create arrays. Open up the terminal and type IRB to start the interactive Ruby shell. We can create arrays using brackets. A equals open bracket and close bracket. And let's see a type of variable, a class, and yes, the data type is array. Another way of creating an array is using the new class method. A equals array new, and it creates and returns an instance of array object. We can set the size of an array while creating the array. A equals array new 5. An array has 5 elements, and all of them are nil. We can set a default value while creating an array. A equals array new 5 test. An array has 5 elements, and all of them are test. We can use blocks while creating an array. A equals array new 5, open a block. X is block variable, X, exponential symbol 2, and it means the square of each value. So it creates an array of squared numbers from 0 to 4. Now, another way of creating an array is like this. A equals array, brackets, and values in parentheses. Another form of array creation. A equals array, values 1, 2, 3 in brackets. Now we can also use ranges to create arrays. A equals array, a range 1 to 5. Now let's create a number array. Numbers equals 1, 2, 3, 4, 5 in brackets. numbers is an array of integers. So let's create an array of strings. Animals equals lion, tiger. Now let's create another one, but this time I want to use mixed data types in the list. So mixed equals lion 462.5. There are string, integer, and float data types in the array. So let's create one more as well. Mixed equals 5, an integer array 2, 6, a string array, lion, a float 4.5. So see that? We can use other arrays in the arrays. So go ahead and get carried array. Okay, so now open your Aptana Studio or any of your favorite development editors. Project name is examples. Then create a file. File name is arrays.rb. Now we can iterate through each item in an array using loops. So let's have a look at how to do it. First, we'll create a string array. Animals equals lion, tiger, leopard. Using a for loop, for animal in animals, puts animal. Save it and run, and it shows each item in the array. Now let's use a while loop. We need a loop variable, I equals 0, while I is less than length of animals array. Puts animals with index I, increment the loop variable, run, and it shows each item in the array. We can use built-in methods to traverse arrays. Animals, each, open a block. A is a block variable, puts A, run, and it shows the result. We can also use the map method. Animals, map, open a block. A is a block variable, puts A. So now you might wonder, now these two methods look like they work the same. What's the difference? Let's look into returning the values of them. So assign returning value of each method to variable, B for each method, C for map method. Now print B and C. Print method does not add a new line, so add a new line. Save it and run. And it shows the values. Each method always returns the same array. The map method returns the last statement in the block. The put method does not return any value, so there are nil elements in return values. So let's change expressions in the blocks. Concatenate each string with itself. Run it again, and it shows the result. Actually, both of them are the same class. So let's check them. Puts, animals, each, outputs animals map. Run it again, and it shows the objects. They are enumerator objects. Enumerator is a class which allows iteration. We can access array items by using different ways. I'm going to show you a few examples. First, let's open the terminal and type IRB to start an interactive Ruby shell. Create a number array where n equals 1, 2, 3, 4, 5. First item in the array, n, index 0. As you know, indexes are 0-based. But what about a negative index? N index minus 1 shows 5. So it is the last item in the array. So yeah, we can use negative indexes in the arrays. We can slice arrays using the start index and length. N start index 1, length 2, and it shows a result 2 and 3 as an array. We can use arrays as items in the arrays. N equals 1, 2, 3, an array for 5, an array 6, an array 7, 8. Shows the array. Now these types of arrays are called nested arrays, and we can access each item in the array. Show item at index 3 of the array. Shows an array for 5. We can access items of the result array. And to access the inner array, another square bracket and index of the inner array are required. N 3 0 shows 4. So let's see the last item in the array. N 4 shows the inner array. N 4 1 shows second level inner array. N 4 1 0 shows 7, the first item in the inner array. We can create arrays using a range. A equals array, a range 0, 9 shows A. We want to create an array of numbers from 0 to 9. Now, arrays are mutable objects, so we can change items. So let's assign a different number to the first index. A, index 0, equals 100. Show the array, and yeah, now the first item is 100. Also, we can change items as a group. Let's change items starting on index 3 and 3 as a length with an array A, B, C. And show the array, and yeah, the items are changed. So in using range and multiple assignments, index and values are either expandable or reducible. So when we assign new values to a part of an array, assigning values evaluate first. A, 3 as starting index, 3 as length, equals an array with a range from 1000 to 1010. So, what's going to happen? Show the array. And as you see, the array is expanded and new values are assigned from index 3. The rest of the items in the array are shifted. So let's do another, but this time, the array index interval will be large and the values range will be short. A, 3 as the starting index, 20 as length, equals array with a range of letters from A to C. Show the array. And yeah, new values are assigned from index 3 to the end. Other items which was given in the interval are removed. Now let's create another array. A is equal to 1, 2. We can append values with 2 less than signs. A, 2 less than 5. Yeah, new item 5 in the array. We can append other data types too. If you go A, 2 less than element as a string, and yeah, it's in the array. We can multiply arrays by numbers. An array, x, multiplied by 4, creates a new array having 4 of the x items. Let's try another one with an array having 2 items. And yeah, it shows the array. We can also use the multiply sign with strings, but it works a bit differently. So let's do an array x, y, multiplied by a, b, c. Shows a string, yeah, but multiplying by a string returns a new string and works like a join operation with a multiplication string. All right, so let's clear the IRB screen. In macOS or Linux, you can use the Control and the L key combination. Since there's no convenient way to clear the console in IRB on Windows, you can just simply emulate the DOS CLS function. Now we can make some mathematical operations with arrays. So let's say that we have 2 arrays. A equals array, a range from 0 to 5. B equals array, a range 3 to 8. We can add arrays. A plus B returns a new array which has duplicate values. We can subtract them from each other. A minus B returns the rest of A with common items removed. And we can find the intersection. A, ampersand symbol B, returns the intersection of A and B. Intersection basically means that common items are in A and B. So we can get the union of arrays. A pipe B returns the union of A and B, and union means all the items in A and B except for duplicate items. Now, there are some methods that are available with array objects. So why don't we see some examples? Open the terminal and type IRB to start an interactive Ruby shell. Now let's create a number array using a range. A equals array, a range 0 to 10. And yeah, these are the numbers from 0 to 9. And we can use the size method to get the length of an array. A, size, shows 11. We can also use the length method to get the length of an array. A, length, shows 11. Max is a method that gives the maximum number in the array or maximum alphabetic order in a string array. A, max, shows 10. Min method gives the minimum number in a number array or the minimum alphabetic order in a string array. A, min, shows 0. The sum method gives the sum of all items in an array. A, sum, shows 55. We can easily get the first item of an array using the first method. A first shows 0. And we can also easily get the last item of an array using the last method. A last shows 10. Arrays are mutable objects, so we can change items. Append is the method that adds an element to the end of an array. A, append 1. And yes, 1 is at the end of the array. The count method returns the count of the number of items in an array. So A, count 1, shows 2 because there are 2 items as 1. The pop method removes and returns the last element from an array. A, pop, shows 1, the last item. Show the array, and sure enough, it's removed. So we can push items to the end of the array using the push method. A, push, Ruby, and there it is as the last item in the array. Index is a method that returns the index of the first matched item in the array. A, index, Ruby, shows 11. So we can delete items from the array using delete as our method. A, delete, Ruby, show the array, and it's deleted. Now we can get items of an array on a specific index using the at method. A, at 9 shows 9. And we can get items of the array in reverse order using the reverse method. A, reverse, returns the array in reverse order as a new array. And we can use the shuffle method to get items in a random order. A, shuffle, returns the array in a random order. Each shuffle operation returns a different random ordered array. Sort is the method that sorts items in the array in ascending order. A, sort. And we can get a string representation of the array using 2s as our method. A, 2s. Now the join method returns a string created by converting each element of the array to a string separated by the given separator. Now if no separator is specified, an empty string will be used. A, join, show the items as a string. And if we use a dash as a separator, A, join, dash, shows a result. We can check items if they exist in the array using the include method. A, include 3, shows true because 3 is in the array. A, include 100, shows false because 100 is not in the array. So let's clear the screen. Now we can use the each method to iterate throughout the array. A, each, a block, x as a block variable, puts x, and it shows each item in the array. We can use the each index method to get an index of elements. A, each index, a block, I as block variable, puts index, I in interpolation. It shows each index in the array. We can also use the each with index method to use both index and value of the array. A, each with index, a block, value and index as block variables, put index and value in interpolation. Shows each value and index in the array. Let's clear the screen again. Now we can use the map method to iterate through the array and evaluate each value of it. So A, map, a block, X as block variable, X, exponential sign 2. Returns a new array having squared values of the array. So we may have some nested arrays. In that case, we may want to see each item in a new array. To make this operation, we can use the flatten method. A equals 1, 2, an array, 4, 5, an array, 4, 5, an array, A, B. A, flatten, and we can use the product method to get the Cartesian product of two arrays. 1, 2, 3, product A, B shows a Cartesian product of the given arrays. So let's do another project. We're going to make a project about a popular concept, and that is palindrome words. So let's get to coding. Open your Aptana Studio or any of your favorite development editors, and we'll create a Ruby project. Project name is Palindrome. Then create a file. File name is main.rb. All right, so what is a palindrome? A palindrome is a word, a number, phrase, or other sequence of characters which reads the same backward as forward. For example, radar. Each of the characters are the same when we split the word in the middle. Another example is madam. And a popular example is race car. Okay, so you get the idea, but how do we implement the code? We can compare character by character, right? Compare the first character with the last character. If they're the same, remove them, and then comparing with the remaining sequence. If comparing continues until no more remaining pairs, then yeah, it's probably safe to say it's a palindrome word. So let's think of a word to check, and we can take it from the user input, a print statement for informing users, puts palindrome words, print word, word equals gets chomp, removing the last new line character from the input. So yeah, we have the word. So let's create a function to implement palindrome checking. Def is palindrome word. We can implement this function as a recursive function, just so that we don't have to, struggle with looping right now. So first of all, if the length of the word is less than or equal to 1, it is a palindrome. If word length is less than or equal to 1, then return true. If the length of the word is greater than 1, we should compare the first character with the last character. Else if word first index 0 is not equal to word last index minus 1, then return false. If they are not the same, the word is obviously not a palindrome, right? Okay, let's move on. Else. Now, everything looks good. Now, we can remove the first and last characters and call the function again with a remaining sequence. Is palindrome word starting index 1, and the length will be word length minus 2. So remove 2 characters, the first and last characters. Now, let's call the function. Puts is palindrome. Is palindrome word? Yes. Now, the program does seem to be complicated, but right now we'll save it and run it. Enter race car, and it shows true. So run it again. Entering madam, shows true. Run again. Let's enter Ruby, and it shows false because Ruby is obviously not a palindrome word, so we know that it works. Okay, so we can simplify expressions using one-line conditions. So let's change conditions to one-liner conditions. And run it again. Entering radar, and it shows true. Okay, so we've completed our program, but there are other ways to check palindrome words. We can use a built-in method of array data type. So let's see how to do that. Let's create a new function. Def is palindrome easy. Word return word equals to word reverse. So this is an expression. If equals returns true, if not, it returns false. So the reverse method returns a reversed array. So let's change the code and run it. Entering Malayalam, and sure enough, it confirms it's a palindrome word. Okay, so in this project, we implemented palindrome checking for words. Now, you can improve on the code for palindrome sentences, but I'm going to have you do that on your own. Hashes is an unordered collection of items. While other data types have only one value as an item, a hash has a key value pair. So we can use symbols, strings, numbers, or any objects as a hash key. Hash values can be any data type, and they can repeat. So let's have a look. Open up the terminal and type IRB to start an interactive Ruby shell. We can create hashes by using curly braces. H equals, open curly brace, and close curly brace. So let's see the data type of variable H. H, class, and yeah, the data type is hash. H equals name, John. Last name, Doe. Now let's look into the details of this hash. So we used name and last name as hash keys. This syntax is called symbol syntax. A symbol is a basic Ruby object. It looks like a variable, but it is prefixed with a colon. Symbols are unique objects and refer to the same object. Symbols are generally used as hash keys. Their performance is probably better than strings. Equal and greater than symbol is a custom key-value assignment syntax for hashes. We can use strings as keys in hashes. H equals name John. We can use numbers as keys in hashes. H equals 1 test. We can use arrays as keys in hashes. H equals an array, test, 1 as key, test value as value. We could also use a hash as a key in hashes. H equals a hash, name, John as key, test as value. Another way of creating a hash is by using the new class method. H equals hash new, and it'll create and return an instance of a hash object. So we can give a parameter to a new class method for storing it as a default value. H equals hash new test, and it returns an empty hash object. But the given value is stored in H default. So another way of creating a hash is this. H equals hash number 105 test in brackets. Now in Ruby we have two different syntaxes for creating hashes. The old syntax is what you just learned. H equals name John, last name Doe. And the new syntax is this. H equals name, colon, John, last name, colon, Doe. So with this new syntax, every key is a symbol, and you cannot specify other types as keys. The new colon notation only works when the keys are symbols. So open up your Aptana Studio, or whatever your favorite development editor happens to be by now, and then create a Ruby project. Project name is examples. Then create a file. The file name is hashes.rb. We can iterate through each item in a hash using loops. Let me show you how to do that. Person equals name John, last name Doe, city London. Using a for loop, for key value in person puts key and value in interpolation. Save it and run it. And it shows each value in the hash. Hash data type has some built-in values and key methods. So why don't we print these methods? Print person keys, run, and it shows the hash keys as an array. Print person, values, run it, and it shows hash values as an array. So we can use these arrays in a while loop. I equals 0 as loop counter, while I less than person length puts person keys with index I and person values with index I increment the loop counter, save it and run, and it shows you the same result. So open up the terminal and type IRB to start an interactive Ruby shell and create an empty hash. Hashes are mutable objects, so we can assign new key value pairs. H, symbol name as key equals John. Show the hash, the new key value is inserted. H, a string last name as key equals dough. Show the hash, and the new key value is also inserted. H, an integer 10 as key equals test. Show the hash, and the new key value is also inserted. H, name, returns the value John. H, city, returns nil because there is no city key in the hash. And we can set a default value for these situations. So H equals hash new. This is a default value. H is an empty hash. H city returns the default value. H test returns the default value. Now there are a few methods that are available with hash objects, so let's give you some examples. Open up the terminal and type IRB to start an interactive Ruby shell. Let's create a hash with a new colon notation. H equals name, John, last name, Doe, city, London. We can use the length method to get the length of the hash. H, length, shows 3. We can also use the size method to get the length of the hash. H, size, shows 3. The 2s method gives a printable string representation of a hash. We can convert a hash to an array by using the 2a method. H, 2a, returns an array. Each item in the array is also an array, and it consists of key value pairs of hash. The min method returns a key value array according to the minimum number in the hash keys or minimum alphabetic order in the hash keys. Hmin returns city as the key value pair. Max is the method that returns a key value array according to the maximum number in the hash keys or maximum alphabetic order in the hash keys. Hmax returns the name key value pair. Now the fetch method returns the value of the matched key if the key does not exist, returns a key error. H fetch name shows John. H fetch tell shows a key error. The keys method returns hash keys as an array. The values method returns hash values as an array. The key method returns matched keys for a given value. So we can check the existence of keys by using the hasKey method. So the key method works the same way. So we can check the existence of values by using the value method. Then we can use the store method to insert or update the values in a hash. H store email john.doe@example.com. Show the hash, and yes, the email key value pair is stored. We can also use the delete method to remove key value pairs in a hash. H delete email, show the hash, and yes, the email key value pair is deleted. Now the merge method merges two hashes and returns a new hash. Common key value pairs are updated with given hash key values. H merge a hash, city, Paris, and a phone key value pair. And that'll return a new hash and overwrite city key value pair with the given pair. The sort method sorts hash keys in ascending order and returns key value pairs as arrays in an array. And we can use the each method to iterate through the hash. H each a block key value as block variables, puts key and value in interpolation. Shows each key and value in the hash. We can use the reverse each method to iterate through the hash with a reversed order. H reverse each a block key value as block variables, puts key and value in interpolation. Shows each key and value pairs in reversed order. And the clear method removes all key value pairs from a hash. H clear removes all. Let's double check. H, yes, all key value pairs are removed. So I think you're ready for another project. We're going to do a project about letter frequency. We're going to analyze a text and then show the letters and frequency of each letter. Frequency is also known as counting letters. So let's start coding. Open up your Aptana Studio, create a Ruby project. Project name is letter frequency. Then create a file. File name is main.rb. Yeah, so we're going to need input from the user. So puts letter frequency, print text. Text equals gets chomp, removing the new line character from the input, and now we have some text. So let's create a function for finding the frequency of letters. Def letter frequency text. So yeah, first of all, we're going to need only letters for counting. Punctuation, not necessary, so we shouldn't include them in the counting. We can use a reference array consisting of letters, so we can compare each character with that reference array. So chars equals a range for lowercase letters, then convert it to an array, plus a range for uppercase letters, convert that to an array, and merging two arrays. So now we can use a hash. We can use letters as keys and counts as values. Frequency equals an empty hash. And now we can use a built-in method, each char, to loop through the text. Text, each char, a block statement, do, char, as block variable. Now we can check if the char exists in our reference array. Chars include chars. Okay, so the logic ought to be that if a letter exists in the hash key list, we will increment the count of the letter. If not, then we will add the letter as a key, and then count of the letter will be 1. So, unless frequency, key, char, the key method checks the existence of any given key in the hash. Frequency, char, equals 1. Else, frequency, char, plus equals 1. Increment a value. And then after the each statement, return frequency. Now, of course, hash is a mutable data type, so we can create keys and values using assignments. So yeah, let's call the function and print the result. Result equals letter frequency, text, puts, result, save and run, entering hello, and it shows the result, the count of each letter in hash form. So let's run it again. Entering Ruby is your friend with some extra exclamation marks. And what's the result? So I think we can print it in a more aesthetically pleasing way. We can directly access the keys and values by using the for loop. For, key, value, in result, puts, key, and value. So let's save it and run it again. Entering hello shows the result. Now we may also sort the result in alphabetical order. We can use the sort method. And as you notice, the letters are both lowercase and uppercase. So we might want to choose one type. Let's do it in uppercase. Text, uppercase. Now before running it again, I want to introduce you to a website. It's called lipsum.com. Now this site is popular among software developers because lorem ipsum is just simply dummy text. We can generate this dummy text, however, according to our needs. So let's copy a paragraph and run it again. Paste it. And look at the results. So until now, we've been using standard input and output for reading and writing data. But it does not remain in memory. After closing the program, it disappears. So we need to permanently store data in a non-volatile memory, such as a hard disk. And we can use files for future use of the data. So a directory is a collection of files and subdirectories. Ruby has a class for handling operations on directories and files. Name of the class is dir. So let's see it in some examples. Open up your Aptana Studio or any of your favorite development editors, and then create a Ruby project. Project name is examples. Then create a file. File name is files.rb. Now, there are many useful methods to work with directories and files in the dir or dir class. We can get current working directory using the pwd method, puts dir, pwd, save it and run, and it shows the current working directory, which is our project directory. Okay, so we can create directories using the mkdir method. Make a new directory, foo, make another directory, bar, save it and run, and refreshing the Project Explorer, and there you see that the folders are created. So we can get directories and files within the working directory using the glob method. I know, I like that one too. Print dir glob asterisk. The glob method takes a parameter as a search pattern. It can be a static string or a full regular expression. A regular expression is a special sequence of characters that define a particular search pattern. So in this example, we are using an asterisk as a wildcard. So every file and directory will be matched. So let's just save it and run it. And it shows all files and directories in the working directory. Now we can change the wildcard for matching only Ruby files. Run it, and it shows the result. So we can use a block with the glob method. Dir glob do file name as block variable, puts file name. Run the script, and it shows each matched file and directory. We can change the current working directory by using the, okay, you got me, chdir method. So let's change it to foo or foo. But let's print the current working directory before and after the operation. So printing the current working directory. Dir, chdir, foo, and printing the current working directory. So save it and run, and it shows the current working directory before and after. We can pass an absolute path to the chdir method. Let's do it again with the absolute path. Run it, and it shows the same result. We can use delete as our method to delete a directory. Dir delete bar, run, and refreshing the Project Explorer. Yes, the folder bar has indeed been deleted. Now, besides using methods directly, we can also make an instance of the dir class. So let's create a dummy file in the folder foo for this example. Folder equals dir new foo. Then just print the directory contents using the with entries property and save it and run, and it shows the content as an array. The entries of a directory include a dot and a two-dot pointer in itself and its parent directory. Now we can pass a relative or absolute path. So let's do it again with an absolute path. Now before we can get the current working directory, run it, and we'll copy the path. And now we can change it with the absolute path, run it, and it shows the same result. We can also use the open method instead of the new method. So run, and it shows the same. So it works with both relative and absolute paths. Let's run it, and it shows the same result. We can also use the each method on the instance, folder, each, do file as block variable, puts file. Run it, and it shows each entry. Now we can specify a directory as a parameter for the entries method. Dir entries user bin, and let's print it. The user bin is a standard directory on Unix-like operating systems that contain most of the executable files. So let's run it, and all the files show as an array. We can also use the for each method to get all entries. So dir for each /user /bin do entry as a block variable, puts entry, run, and it shows all files. Another way of getting all entries, asterisk as a wildcard to match all files and directories. Let's print it, run it, and it shows all as an array. So Ruby has a built-in function called open to open a file. This function returns a handle, a file object for reading or modifying the file, right? So we can use different modes while opening files. We can open the file for reading. If no mode is specified, this is the one that's used by default. Open the file for writing, creates a new file if it does not exist, or truncates the existing file. Open the file for exclusive creation. This operation fails if the file already exists. Open the file for appending. It doesn't truncate the file, and it creates a new file if it doesn't exist. Open in text mode. This is also a default usage. Open in binary mode, and open the file for updating. So let's see how this works in a few examples. So let's open up a file in write and updating mode. So File, new test.txt w plus, and it returns a file handler. So let's assign it to a variable f. So there is no test.txt, so it's going to be created. Now, we can also use an absolute file directory. So we can use the puts and write methods to write strings into a file. F puts, first line, F write, second line, F write, third line. And now we should close the file handler using the close method. Closing a file will free up the resources that were tied to the file. Save it and run the script. And the file is created. So let's open it. And as you can see, the first line has a new line character. The other lines do not, because the puts method adds a new line character at the end of the line. So we can use a block with the open method. File, open, test.txt, R for read mode, do file as a block variable, puts file read. So save it and run, and it shows all the content of a file, because the read method gets the entire file content, right? Okay. So this usage is an elegant way of doing your file operations. Ruby can take care of closing up the file. So yeah, let's open the file. File mode is reading. And we can use the read method to read the file. The read method also takes size as a parameter. The file cursor position changes after the read statement. And if no size is specified, it reads in the rest until the end of the file. So further reading returns an empty string. So if we want to bring the file cursor to the initial position, we can use the rewind method. We can use the read line method to read it line by line, and it reads it until the new line, including the new line character. Each red line statement returns a line, and further reading returns an empty string. So let's run it, and it shows the first line again. We can use the each method on the file handler to read it line by line. F, each, a block, do, line as block variable, puts, line. And run it, and it shows each line. We can use an absolute path as our method to get the absolute path of a file. File, absolute path, test.txt, and then print it, run it, and it shows the absolute path. So if we have an absolute path of a file and want just the file name, we can use the base name method, base name with absolute path, run it, and it shows the file name. Now, let's say if we don't want an extension, we can specify the extension as a second parameter for the base name method. Run it, and it shows a file name without the extension. We can use some file utility methods according to whatever we need. We can check the existence of a file with the exists method. puts, file, 2 colons, exist, test.txt, run it, and it shows true. So we can check a given file name if it's a real file or not with using the file method. Run it, it shows true. We can also check if a given file name is a directory by using the directory method. Run it, and it shows false. We can rename files using the rename method. File, rename, test.txt, foo.txt, run it, and checking the Project Explorer, and sure enough, it is renamed. So we can also delete files using the delete method. File, delete, foo.txt, run, and checking the Project Explorer, sure enough, it's deleted. So here we are in another wonderful project, and what we're going to do now is write a program so that we can search within files. So let's get to coding. Open up your Aptana Studio or any of your favorite development editors and create a Ruby project. Project name is Searcher. Okay, so then create a file. File name is main.rb. Okay, now I have 2 files on the desktop. The first one has information about Ruby programming language, and the other one's about London. Both of them are taken from Wikipedia. So I'm just going to copy them into our project. And yeah, it's going to do a simple search program, so we're going to need a search key, and we can take it from the user input. Puts, search in files, print, key. Key equals gets chomp, removing the new line character, and yeah, now we have the search key. So now let's create a function to implement searching. Def search key. Now, of course, we are going to be using files and directories, so the built-in dir module will come in handy here. You can get all files and directories using the dir glob method. The method looks into the current working directory, which is our project workspace, and then we can specify a pattern to get only the files having the txt extension. And yeah, so it's going to return a list of text files. So we can use a block to iterate over the result list. File name is block variable. F equals file, open, file name. So yeah, we've got the file now, and we can read it line by line using the each method. F, each, do, line, using block. We can use the include method to check to see if its given value is in the sequence. If, line, include, key. If true, then return the file name. Now, of course, we should close the file at the end of each file operation. So let's call the function file name equals search key puts file name Let's take a word from london.txt and save it and run it. Entering London, and it shows the file name is london.txt. So run it again, entering Ruby, and it shows the file name is ruby.txt. So we can show the file name, which has our search key, but can we show the line number as well? I believe so. Yes, we can. Changing to the each method with each with index adds an index as a second variable to the block. Then add index to the return statement, and yeah, we can do it just like that. Actually, yes, as you have now guessed, it is an array. So, get the line number from the function call. Then print it to run it again, entering London, and it shows that the line number is 0 because indexes are 0-based. Add 1 to the index to make it correct. And run it again. Now it shows the correct line number. So in london.txt, there are more than one occurrences of the London word, right? But we're only showing the first one. What would we have to do to show all the others too? Can we? Of course. We can use a hash. See? I read your mind, right? We can use a hash for storing all of our search results. So first up, we've got to create an empty hash result. We can use line numbers as hash keys, file names as values. Result. Line number as key equals file name as value. So at the end of the function, we should return the hash, return result. Actually, we might not want to use return because, as you know, in Ruby, the last statement works like a return statement, right? So now we can change the function call. Returning value of the function is a hash, so we can check its length to find out if it is a successful operation. If result length is greater than 0, then print all key value pairs in the hash. For key value in result, puts file name value line number key. Else puts not found. Yeah, so let's run it again. Entering London, and there you see all the occurrences. Okay, so our search program works really well, but there may be a problem. You know what it might be? We are reading the whole file to memory, right? So the problem is that it's not going to scale very well. When we try to read files measuring in gigabytes, our computer, well, you can imagine what that's going to do. It's going to freeze up and try to read and allocate memory, and it's just going to be a disaster. So we can use a different method to lighten the possible memory problems. This method is the for each, and it's inherited from a built-in module, I/O. Line-by-line reading is very fast. So first, let's create a function called find, The function structure is going to be the same as the search function, using result, hash to store result, dir glob to get all text files, file for each, file name, each with index, do line and index as block variables, if line includes the search key, store line numbers and file names in the result hash, and return statement result, change the function call, run again, entering London, and this shows a result. And now the sample files are small files, so the performance will change for large files. Got it? Get it? Got it? Good. All right, let's move on. Now, as I might have hinted to you before, or it might be your experience, that programming is, or can be, all right, so it's always, error prone. We will make errors. There's just no doubt about it. In some of the previous lectures, we've learned that some of the errors haven't even occurred until the program is run. These types of errors are called runtime errors. They can also be called exceptions. And let's see some of that in some of our examples coming up. I want you to open up your Aptana Studio, or whatever your favorite development editor might be by now. Project name this time is examples. Then create a file. The file name is exceptions.rb. Now, before using the exception handling structure, let's try to understand exceptions by using the raise keyword. We can use the raise statement to raise an exception. Puts before exception, raise, puts after exception. So yeah, let's run the script. And it shows first the print statement and an unhandled exception on line 2, right? So as you can see, the exception breaks the execution, so the last line won't be executed. So we can specify a message in a raise statement. An exception, run, and it shows the exception with a specified message. We can also set the exception type. Exception class is the base class for all exceptions. Run it, and it shows the exception. We can use conditions with raise statements. So let's say that we have a variable a, which equals 5. Then if a greater than 5, raise the exception, run it, and no exception occurs, and the last print statement is executed. So let's change the condition. Let's run it, and the exception occurs. So let's do some exception handling. The exception handling structure is a begin rescue statement. So begin rescue. Everything from begin to rescue is protected. When an exception occurs during the execution of this block, control is passed to the block between rescue and end. Puts, processing, puts, exception, save it and run, and it shows processing, So there is no exception. So let's raise an exception. Raise an exception. Run it, and it shows exception handling. We can specify exception type in the rescue statement. Arrow notations define exception instance. Puts E message. And yeah, we get the exception message over the instance. Run it, and it shows the exception message. So we can specify another type of exception, such as a name error, and changing the message. So run it, and it shows the custom message. So let's make another one. Begin rescue statement. Print statements before and after exception. A mathematical expression which causes a divided by zero exception. And rescue statement using a basic exception class. Print exception class and exception statement. Save it and run the script. And it shows a zero division error and divided by zero as the error message. So when an exception occurs, Ruby generates a backtrace. A backtrace, or a stack trace, is a sequential representation of the stack method calls in a program when an exception is raised. So let me show you, well, let's print the backtrace. E, backtrace, and backtrace is an array, so using the inspect method to print is really good. Run, and it shows the backtrace. Now we can use the each method as well. E, backtrace, each, a block, location as block variable, puts, location. So let's run it, and it shows each call stack. And they point to line numbers. That is where the exception occurs. Another way of getting the exception is using a special global variable, puts, global variable class and message. Now this global variable stores the latest exception. Run it, and yeah, there's the same result. And another special global variable stores the latest backtrace. And we can use the each method to show error locations. So let's run it, and it shows the backtrace. Now we can change the exception rescue statement and set a certain type, zero division error. So let's change the code and try to call a special method for numbers on a string. Test, odd. The odd method checks if a number is odd or even, but we're going to use it on a string, so an exception will occur. Now we can use multiple rescue statements. So rescue, exception E, print the exception class and message. So run it, and it shows a no method error exception in message. So we can change the general exception type to no method error. Run it, and that shows the same result. We can also use the else statement with a begin rescue statement. So else puts no error, removing the error-prone code. Run it, and it shows no errors. The else statement is executed. So this kind of works like an if-else statement. If no exception occurs, the else statement executes. So let's see, adding an error-prone code, 100 divided by 0. Run it, and you see the rescue statement is executed. Now, sometimes we need to ensure that some execution is done at the end of a block, regardless of whether or not an exception occurs. In these types of situations, we can use the ensure statement. Ensure puts ensuring execution. Run it. And yeah, so the ensure statement is executed without an exception. With an error-prone code, run it, and the ensure statement is executed after the exception by using the ensure statement. And let's do another example. Create a dummy file. File name is test.txt. Now let's try to do a file operation in the begin rescue block. So file name equals test.txt, begin, file equals file, open, file name. If file is a valid file handler, then puts file open successfully. Rescue puts exception. Run it, and it shows a message, file opened successfully. Now, if we change the file name, the file operation raises an exception. So run it, and it shows the exception. So in these types of situations, we can use the retry statement to start over at the beginning of the statement. Change the file name, give the correct name, and call retry. Run it, and see, it shows the exception at first, and then the retry statement is executed. Pretty cool, huh? Now, in this lecture, we're going to try to understand the throw-catch statement in Ruby. It's not that difficult, but I'm just going to take you through step by step. First, open up your Aptana Studio, or whatever your favorite development editor is, and then create a Ruby project. Project name is examples. Okay, then create a file. File name is throw_catch.rb. Now, in the previous lecture, we learned how to use the raise and rescue statements for abandoning execution when something goes wrong. But sometimes we need to be able to jump out of some deeply nested statements during normal processing. So that's when the throw-catch statement comes in very useful. So I'll show you in an example. Let's say that we have a double array and we want to search an item in it. Array equals first item, an array, foo, bar, wanted, test. Second item, an array, 1, 2, 3, 4, 5. Third item, an array, A, B, C, D. So let's use the each method for iterating. Array, each, do, row as block variable. So row is also an array, so row, each, do, item as block variable. Then if item equals wanted, then we want to store it in a variable, search. So let's initialize a search variable with nil. Search equals item. Now let's define a counter to count how many search attempts are done. Counter equals 0. And then just increment the counter. Yeah, so let's print out search and our counter values. Puts counter, counter, puts search, search. Okay, so let's save it and run the script. And yeah, the search key is found and iteration is executed 13 times. Now, why? As you see, our search key at the third index of the inner array, so the counter should be 3. So what we'll do is use a break statement to break the loop execution when it finds the search key. So run it, and the counter is still very high. Break statement didn't work as we wanted it to, because we're going to need to jump out from all nested statements. Now, you might think that we can use a raise rescue statement. Yeah, you're right, we can use it. But Ruby creates a backtrace for raise rescue statements, so it's not good for performance. So if we use that throw catch statement, well, let me just show you. All codes need to be in a catch block statement. So, catch found as a symbol. It can be a symbol or a string. Indent that, and end of statement. Remove break statement, throw, found. Run it, and there you see that the counter is 3. So there are no other unnecessary iterations. You see why that's more efficient? Excellent. So we can assign values with a catch statement. And let's change the throw pass item as a second parameter. Run it, and it shows the same result. And one more thing that we might want to do is combine the throw and if statements as a one-liner. So let's run it, and it shows the same result. Now, you've heard me say before, but I'm going to say it again, Ruby is a perfect object-oriented programming language. Object-oriented programming is just one programming approach. It's based on objects, which may contain attributes and methods. So in this section, I will introduce you to objects, classes, inheritance, polymorphism, as well as the concept of encapsulation. So basically, an object is a software bundle of related data and behavior. Objects are often used to model real-world objects. A class is a prototype from which objects are created. So why don't we see that in some examples for deeper understanding? Open up your Aptana Studio or any of your favorite development editors. Project name, examples. Okay, then create a file. File name is class.rb. So let's say that we want to model a person as an object. And we need to create a prototype for this person object. So we'll use the class structure for creating objects. We use the class keyboard to define a class. So class, person, end. And we don't want to implement the person class right now because it's an empty class. So in Ruby, class names begin with a capital letter. Names may contain more than one word which are run together with each word capitalized and no separating characters. So this is called camel case. We can create instances of this class. An instance is a specific object created from a particular class. So in other words, P1 equals person new. P2 equals person new. And the new method initializes and it returns the instance of the class. So now let's print these instances and save it and run. And it shows that the person objects are at some address in memory. So sure, we constructed instances from the person class, and right now they're in memory. So we can find out the class of an object by using the class method. So let's run it, and yes, it shows that this is a person class. Now let's create a person class. Class, person, end. Create an instance of it, P equals person, new. When we create a new instance of a class, a special method, the initialization method, is called automatically. So now what it does is it uses parameters to create instance attributes. In other words, let's say that we want to define the name and the age while creating an instance. So why don't we see how to do that? Def initialize name, age, then in the method body, at name equals name, at age equals age. So as you're seeing, instance variables start with the at symbol. Now we can create a person instance with a name and an age. Change new method John 25. Okay, so we can create an instance with specified parameters. So let's create a method to display detailed information of this instance. Def display person puts name, age, age. Now we can call the method display person over the instance, run it, and it shows name, John, age 25. So what do you think? Can we access attributes over the instance? Well, let's find out. Print name, run it, and we get a no method error. In Ruby, instance variables cannot be accessed directly. We need to use a getter and setter as our methods for accessing and changing instance variables. So we can define a method to get the name variable, def name, instance variable, Now we can get the name attribute using this method. Run it, and it shows John. Now, what about assigning a new value to the name attribute? P, name, equals Jack. Run it, and we get a no method error. It says that the assigning method is an undefined method. So that means we need to define a setter method. Def name equal symbol new name. Name equals new name. Save it and run it again. And there it shows the new name as Jack. Okay, so these methods are called getter and setter, right? Ruby has a feature called accessor methods to make instance variables available for outside of the class. We can use the attr reader feature instead of getter methods. Attr reader name in a symbol notation. So now we don't need this getter method anymore. Run it, and it shows the name. We can also pass other instance variables with a comma. So let's print age 2. Run it and show name and age. Now, what about the setter methods? Yeah, so we can use attr writer instead of the setter methods. Attr writer name age. Now let's assign new values to name and age. New name Jack and new age 30. Save it and run the script, and there you have it. It shows the new values. Now, if we are using both reader and writer methods on the same variables, Ruby provides yet another method instead of using both of them. Attr accessor name age. Run it again, and it shows the same result. A constant has a name starting with an uppercase character. Now, it should be assigned a value at once. So Ruby allows assigning a constant, but generates a warning, and we should not reassign constants. Constants may be defined within classes, and they are accessible outside of that class. So let's create a class, person, end. Now create a class constant, message equals class constant. Now we can access the constant. Puts person, 2 colons, message. Save it and run the script, and it shows the value of the constant. So naming the constant has only one rule, that is starting with an uppercase letter. But by convention, we'll keep using constant names in uppercase. So rewriting it in uppercase. Run it again. And it shows the result. Now in Ruby, there is another concept, and these are class variables. The class variable is a variable which is shared between all instances of a class. So class variables are prefixed with 2 @ symbols. Let me show you. Counter equals 0. Class variables must be initialized within the class definition. So let's use this variable as a counter for counting class instances. So we need to increment it in the initialize method, and then we can get the current instance count. Def initialize, increment the counter by 1. Okay, so let's create some instances of the person class. P1 equals person, new. P2 equals person, new. And let's print the counter. Puts person counter. Run it, and we get a no method error. Class variables are not accessible outside the class. So we need to define a getter method or a class method. Class variables are shared between all instances of the class. So the class method syntax is a bit different. I'll show you. Def self counter. Counter. The self keyword refers the class to itself. We can also use a class name instead of the self keyword. Run it, and it shows 2. And yeah, that's because there are 2 instances of the class. So let's create another instance. Run it again, and sure enough, it's 3. Now what about setting a new value to a class variable? Person counter equals 5. Run it, and we get the no method error. So we need to define a setter method for the class variable. Def self counter equals new counter. Counter equals new counter. Run it, and it shows the new value of the class variable, counter 5. Inheritance is a fundamental concept of object-oriented programming. We can define a new class by extending an existing class. The new class may have some or all of the main class characteristics. The new class is called derived, or a child class. The existing class or main class is called the base or the parent class. The child class inherits features from the parent class, just like you and me, but it adds new features to it. So that results in reusability of the code, so it reduces development time, right? So let's see how to do that in some examples. Let's say we want to create an employee object. The employee is a person, and for simplicity, we just want to keep it to name and the age of the person. So we're going to create a person class, person, end. Okay, so now let's create the employee class, deriving from the person class. Class, employee, less than symbol, person. Now the parent class should be set in the class definition. The less than symbol is used to extend the syntax. So initializing the person class, def initialize name age. We want to create the person object with the name and age while initializing. Name age equals name age parallel assignment. So yeah, let's write a method to display the employee information. So def display info puts name in interpolation, and age. Yeah, so we can use instance variables, class variables, or others having their own notation without curly braces in interpolations. So, okay, so creating an instance of employee, E equals employee, new, John, 25. Calling display method, E, display info, save it and run, shows name and age of employee. So we can call methods of the parent class. So why don't we create a test function in the parent class? Def, test, puts, test statement, and yes, calling the test function over the child instance, run, and it shows the test statement. Now, in Ruby, we can find out all the parent classes of a class using the ancestors method, employee, ancestors. So this method returns an ordered array of classes. So let's print it out with the P method. Run it, and it shows the classes. Employee, itself, first parent person, object, kernel, basic object. Now let's print the string of class ancestors. And yeah, so you notice that the last three classes are the same for both of them. Object is the default parent of all classes in Ruby. Kernel is the module that contains all object manipulation methods. And basic object is the top parent of all the classes. It contains the bare minimum methods for object creation as well as object comparison. So in the previous lectures, you may remember that we've learned how to create modules. But how do we use modules in classes? Let's see that in an example. So let's say that we have a module with a dummy method, module A, def, dummy, puts, dummy from module A, then create a class, class worker, and it has a method, run, def, run. So let's embed the module in the class. We use the include statement in the class for embedding. Include module A. Now we can run module methods in the class. Dummy. And now let's create an instance of the worker class. W equals worker, new. W run. Save and run the script, and it shows dummy from module A. So yes, we could call the module method. The include statement embeds modules, so module methods are available in the class. So let's print ancestors of the worker class. P, worker, ancestors, run, and it shows all the hierarchy. So we can use modules to organize our code using composition rather than inheritance. We can also include more than one module in a class. So why don't we go ahead and create another module. Module B. Include module B. So now we can use the module B methods too. Run it, and it shows a result. So if you noticed, module B is before module A in the ancestors chain, and the dummy method in module B is executed. So what does that mean? It means that if the included modules have the same methods, the method in the last included module will be available. Ruby also has another feature for importing modules into classes. Using the Prepend statement, we can use modules in a class. Now, it works like an include statement, except that instead of inserting the module between the class and its parent in the ancestor chain, it will insert it at the bottom of the chain, even before the class itself. So that means that when we want to call a method on a class instance, Ruby will look into the module methods before the class methods. Why don't we see that in an example? Let's create a worker class, class worker, and a method with some parameters, def run params, and let's create a module. Module, worker debugger, and that also has a method, run, same method name and parameters, def run params, puts running with params, params inspect. Result equals super. Okay, so what is this super keyword? The super keyword is used to call the same method on the direct ancestor all the way up the chain of the class that worker is part of. So, puts completed and result. Now we can implement the run method in the worker class. Puts working on params, params inspect. So let's do a simple map operation to return the square of params. Now, as you know, in Ruby, the last statements work like return statements. And we can use that to our advantage. Params, map, a block, I as block variable, I exponential symbol 2. Now embed the module in the class using the prepend statement. Prepend, worker debugger. Now let's create an instance of the worker class. W equals worker new. W run an array 1, 3, 5 as a parameter for the method. Save it and run, and it shows the result. So let's understand this execution order. First, the module method is executed, printed running with params. Then the super keyword calls the run method in the worker class, and the result variable stored the returning value from the maps operation. Then the last print statement worked in the module and then printed the result values. Now let's print ancestors of the worker class. Run, and it shows the ancestors chain. As you can see, the worker debugger is before the worker class in the chain. Ruby has another feature for importing modules in a specific class instance. Using the extend statement, we can use module methods in a class instance. So let's see that in an example. Let's create a module, module A, and a class method, def self, method 1, puts. Method 1 is a class method and an instance method, def. Method 2, puts. Method 2 is an instance method. Now let's create an empty test class. Class test. So now create an instance of test class, object equals test new. Okay, let's apply the extend statement in this specific instance. Object extend module A. Now let's try to use the module A methods. Object method 1, save it and run, and it shows an error, undefined method 1. So let's try to use another one. Object method 2, run, and it shows the print statement. So yeah, see how we can use instance methods over this instance. So the extend keyword allows us to use the methods of the module. So method 2 is not exactly a class method, but a method to the instance, which we called extend. As we're doing it inside of a class definition, and the instance in there is the class itself, it looks like a class method to Ruby. Polymorphism is the ability to present the same interface for differing underlying forms. So if we think about roots of a term, it should become obvious. Poly means many, and morph means change or transform. So in our context, we can say that many different behaviors can be obtained from the same interface. Why don't we see an example for a deeper understanding? Let's say that we have two different types of documents derived from the same class. Both of them have the same functionality, print method. Now, if we want to call the same method for each one, the result will be different for each one. So let's create classes. Class, document, and it has an initialize method, def, initialize, title, title equals title. And now if we have a PDF class derived from the document class, class PDF derived from document. And it has a print method, def print. Puts printing PDF title. And yeah, we can use the instance variable in expression without curly braces. So we'll copy and paste and do the necessary changes. So now we have a word class. So now we have two different classes derived from the same class, and they have the same methods, but they work differently. So now we'll create instances of them. Word, new, Ruby examples, print, PDF, new, polymorphism, print. I'll save it and run the script, and the print method returns different results for each one. So this type of polymorphism is polymorphism with inheritance. Okay, so you think that was great? I've got another one for you. I've had to wait this long to tell you, now I just cannot bear it any longer. In Ruby, there is another concept called duck typing. Now, duck typing is a programming concept that is primarily concerned with methods. The methods that can be run on an object rather than the class of the object. In Ruby, we can pass an object to a method in another class so long as that object can take that method. The name comes from the phrase, if it looks like a duck and quacks like a duck, then, well, it's got to be a duck. Okay, so Maybe it's not as funny when I say it out loud. But here are a few examples for better understanding. So why don't we say that we have two different classes, WhatsApp and Skype are classes. Class, WhatsApp, and class, Skype, end. And they each have a method, but the method is the same for each one. Def, call, puts, WhatsApp, call, def, call, puts, Skype call. Now we have an array that contains class names. App equals an array, Skype, WhatsApp, app, each, a block, do, object as block variable, object, new, call. So save it and run it, and it'll show different results from the same method over different objects. So yeah, duck typing allows us to call the same method over different objects without even considering the object types. So remember, if it looks like a duck, encapsulation is an internal representation of an object that is hidden for other objects. Encapsulation can be used to hide variables and methods. They can only be accessible in the object. So why don't we see some examples for better understanding? Let's create a person class. Class, person, def, initialize, name, profession, name, profession, equals name, profession. Okay, so now create an instance. P equals person, new, John, doctor. Now, why don't we print the instance variable name? So puts P, name, run, and we get a no method error. Now, in previous lectures, remember that we already learned about accessor methods in Ruby. The Ruby language encapsulates class variables, so they are not accessible outside the class. So we need to define a getter method to access the variable. So let's do this. Def, name, name. So run it, and it shows the value of the name variable. So we can use instance methods that can be created to open a defined way to access the logic inside of an object. Let's do this. Def, info, return name and profession in a string representation. Puts P, info, run it, and there's the result. So we can use methods to update instance variables. Def, set, profession, profession, profession equals profession. Now, let's change the profession. P, set profession, computer engineer, run it, and you see the result with the updated value. In previous lectures, we have learned about inheritance, that a child class can use the parent class, right? But we can always override the parent class methods because we may want to implement different functionalities. So I'll just show you an example instead of talking more. So let's create an animal object, and some other objects will be derived from that animal object. So first, class animal, def swim puts animals can swim. Now, what about creating a tiger class? Class tiger animal. We don't want it to implement right now, so tiger is a child of the animal class. So, okay, so let's create an instance of the tiger object. So tiger equals tiger, new, tiger, swim. So save it and run it, and it shows animals can swim. So yeah, we could call a parent class method. We can override parent methods. So let's override the swim method. Def swim puts tigers can swim. Save it and run it again, and it shows tigers can swim. So Ruby provides some overloading methods. We can use this generic functionality with overriding in our classes. So let's see an example. Let's say that we want to create a point class to represent two-dimensional vectors, right? So class, point, def, initialize, x, y, x, y equals x, y. And define accessor methods for instance variables. attr accessor x, y. So now we can access and change the values of instance variables. Right, so let's create an instance. P equals point, new, 2, 3, puts P. Okay, save it and run it, and it shows the object with some address. Now the built-in method toS can also be used. Let's save it and run, and it shows the object with some address. It means that the toS method is called in the class while printing the object directly. So we can override the toS method to show a string representation of objects in a class. Def toS x and y values in a string representation. So run it again, and it shows our string representation. So the toS method is called automatically while printing the object. Now, vectors can be used in mathematical expressions. So does that mean that we can use our point class in a mathematical expression? Why don't we try and find out? Let's create two instances, P1 and P2. P2 is point 4, 7. Now add P1 to P2. Run it. Okay, so we get a no method error. The plus method is an undefined method for the class. So we can overcome this error by using operator overloading methods. So why don't we give that a try? Let's override the plus method. def plus other point new instance variable x plus other x instance variable y plus other y. Now let's run it again, and there's your result. There are many operator overloading methods. Don't want to get into every single one of them here, but it starts off with a basic subtraction, multiplication, division, and power, and all that. You can check all of them out in that Ruby documentation, because I know you haven't looked at it yet, have you? Now, also in Ruby, we can define methods as public, private, or protected. But it works a bit differently than other programming languages. So, as usual, let me show you by example. Class A, def, method 1. Puts, method 1 is a public method from self class. So yeah, every method is basically a public method unless a private or protected declaration has been pointed out. So if we want to define a private method, we will use a private declaration, and then between this declaration and the end of class or another declaration, and then each method is accepted as private. Now, private methods cannot be accessible outside the class. Def, method 2, puts, method 2 is a private method from self class. Now let's create another class which inherits the A class. Class B inherits A, def, test. Call method 1. Create an instance of B. Save it and run. And it shows you the result. So yeah, because it's a public method, that means that we can call parent class methods. So let's change it to method 2. And sure enough, we get a private method error. Now we cannot call private methods with an explicit receiver, but we can call a private method from within a class it is declared to, and as well as all subclasses of whatever class it is. So let's make declarations like that. It also makes our code much clearer. We can make a declaration above the methods or as a statement, just like that. Now, what about calling private methods with the self keyword? However, as soon as we try to use an explicit receiver, even if the receiver is self, the method call will fail. So, we can't call a private method with an explicit receiver. We can never call it from outside the class hierarchy where it was defined. So, what about the difference between a protected method and a private method? They are a bit different. So, why don't I just show you how to do it? Def, method 3, puts, method 3 is a protected method from self class. We can make a declaration above the methods or as a statement, just like that. Now we can call a protected method from within a class that it is declared in, as well as all subclasses of this class. Of course, we cannot call a protected method outside of the class. We can call a protected method with an explicit receiver as long as the receiver is self or an object of the same class as self. You're ready for another project, I can tell. So in this project, we will make a cryptocurrency converter. As you probably know, cryptocurrencies have been very popular over the last few years. So this user will choose crypto coins and give an amount, and our application will calculate the price in US dollars or euro according to the user's choice. So open up your Aptana Studio or any of your favorite development editors and create a Ruby project. Project name is Crypto Converter. Then create a file. File name is main.rb. And we're going to use an online free cryptocurrency application programming interface service, or API. And yeah, this website, cryptocompare.com, in case you didn't know, provides free cryptocurrency live pricing data. So we're going to implement our application using one of these service methods. There are, of course, many different service methods in this API. And we're going to use the price service. So there are many optional parameters to call the service, but let's use this for our example. Execute call returns a response for 2 coins, BTC and ETH, and it returns structured data. Now, this type of structure is called JSON, which is a lightweight data interchange format. So we can change the result using URL parameters. There are 2 key words in this URL. fsims refers from symbols. tsims refers to symbols. And we're going to create the service URL using 5 popular cryptocurrencies: BTC, Bitcoin, ETH, Ethereum, XRP, Dash, and LTC, Litecoin. And yet we want to convert them to US dollar and the euro. Yes, we will use this JSON result. And each cryptocurrency has a price in USD and the euro. So as you see, the result is in a formatted type. Raw form is like that. I'm using a Chrome extension, the JSON formatter, so that it prints nicely. We can design our project in a modular perspective, so each class will be in its own file. So we'll need a starting point for executing as our main program. So in this file, we will show a menu to the user. Okay, let's implement the menu function. Def, menu. We will show a list of instructions to the user and take the choice of the user. We will use an infinite loop structure to execute the program continuously until the user wants to quit it. We can use kernel loop statement, loop, do. Let's print the menu instructions. Puts, cryptocurrency converter, and by using the center method, it's going to make it look nice and symmetrical. So puts A, convert to USD, puts B, convert to euro, puts Q, quit, print, action. Take input from the user, choice equals gets, chomp, remove the new line character, add a break statement to exit the loop, break, unless choice is not equal to Q. So if the user enters Q, the program will be terminated. Now, call the menu function. So let's run the program to check the menu. Enter A. Shows the menu again because we have not implemented any operations yet. So enter Q. Program is terminated. So yeah, our menu works great, and we can start to implement the other classes. So why don't we start with a coin class? We need a coin class to save each crypto coin price. So we'll create a new Ruby file. The file name is coin. Now the coin class will have a name or symbol, price in USD, price in euro. And we can set these values while creating the coin objects. Remember? So class, coin, def, initialize, symbol, USD, euro, assign instance variables using parallel assignment. So symbol, USD, euro, equals symbol, USD, euro. And now we'll need to access the instance variable outside the class. So we'll use the statement attr accessor. And that's all. Yeah, it's a simple object. So now we need a manager class to manage all the operations. Create a new file. The file name is manager. So let's implement the manager class. So class, manager. The manager class will manage all operations. It will get recent values of cryptocurrencies from the API and create all coin objects and make all calculations. And after creating coin objects, we need to keep it somewhere. So we can use a hash for this purpose. We can use coin symbols as hash keys, coin objects as hash values. So let's create a hash repo. And we can use it as a class variable. And initialize method. So let's create a method to make parsing and creating coin objects. Def, initialize repo. We will call it while initializing the manager class. So we need to get values from the API and parse them. We need to do a web scraping operation, that means. We can do it in a method. So def web scrape URL, and we need the URL of the API service. So we can copy and paste it. We can use the built-in URI and net HTTP modules to get the response of a service call. So require URI, require net/HTTP. Now create a URI object using URL. Now we can use the methods of the net HTTP module. And we can use a get method. And it takes the URI object and it returns a string response. Now call it with the initialize repo method, response equals web scrape. And yeah, we have response data. We can create our coin objects using this response data. So let's keep going. We'll make parsing and creating coin objects. And now we need to parse the response JSON data. And for that, we can use a built-in module for parsing. This module is JSON. So we'll require JSON, and the JSON module has a method, parse, to parse text, JSON, parse, response, and parse method, and that returns an object that we can iterate over. So now we can loop through JSON using a for loop. For, symbol, values, in result. Each symbol will be the key of JSON data, and values will be the value of the key. So let's create coin objects. So we need to import it. Require coin equals coin new. Coin class takes 3 parameters while initializing. Symbol as symbol, USD, and euro in the values array. Okay, so now the coin object is ready. So now we just add it to the repo hash. Repo symbol as a hash key equals coin. Alrighty then, let's go back to the main file. Now, the manager class is not imported, so let's import the class. Require manager. Now we can create an instance. Manager equals manager new. So now we can start to implement conditionals, and we'll start with the USD conversion. Case, choice, when A. Now, I think it's a good idea to first show all the available coins to the user so that the user can choose one of them, right? So we'll need to get an available coin list. So in the manager class, we can create a method to return a coin list. Def coin list, and we can get the list from hash keys. Repo keys. Now call up coin list and save the list as a variable. Coin list equals manager coin list. Puts available coins. Now let's print the list, and we can use the join method to get a string representation. And using the center method, so we show the available coin list. But now we need to get that amount and the coin from the user input. Print coin symbol equals gets chomp. And now we need to convert the user input symbol to uppercase for checking existence in the available coin list. Print amount equals gets chump. Of course, it should be an integer, so using the toI function. And let's check existence in the available coin list. If coin list include symbol, else puts symbol is not available. And using the center method to draw attention to it. Yeah, so this is good. Let's implement the if condition. We have all the values. Now we need to make calculations. We can create a method in the manager class. Def calculate amount symbol 2. 2 is for USD or Euro. It refers converting into which currency. And take the coin from the repo dictionary according to the coin symbol. Coin equals repo symbol. And now we have the coin. Amount multiply by coin objects have USD and Euro attributes, so we can get each attribute using the send method. The send method uses symbols as parameters, so let's convert it to a symbol by using the toSym method. And yeah, the last statement of that method will return the calculation. And let's go back to the main file and call the method. Result equals manager calculate amount symbol, and we are in the USD calculation, so USD, and now we get the calculations result. So let's print it. Put amount symbol equals result in USD. And then use the center method. And using some print statements, it'll look nice. So yeah, let's check it all out, and it looks pretty good. Everything looks okay. So let's run the script. Choose USD, shows available coins. Coin is BTC, amount is 1, and it shows the result. So yeah, it works great too. Oh gosh, I got all excited there. So let's do another one. Coin is ETC, amount is 1, and it shows that ETC is not available. So I'm going to enter Q to terminate the program. Okay, so we can implement a second condition, the Euro conversion. Euro and USD calculations are pretty similar, actually. So we can take all statements in another function and then call the function with a parameter. Follow? Here, so let's create a function, def, submenu. Now we need to make it parametric, right? So we can use the manager and to as parameters. Cut the code block and paste it in the function. We'll make some necessary modifications. Now, change the conditionals. So yeah, call submenu function with USD. And call it with euro. And yeah, so now it looks like our program is completed. So let's run it and see. Convert to euro. Coin is XRP. Amount is 1. And shows a result. Let's try another. Convert to USD. Coin is LTC. Amount is 100. And it shows the result. Good work. So it works great, huh? Let's terminate the program. So we've completed the project, and you can always go back and improve it by adding some new features. This API, as I mentioned before, provides a whole bunch of data, so you can implement a variety of different functionalities. Go for it, really. But come on back for the final project. Right, so I wasn't teasing you earlier. This will be our final project. Congratulations, you've made it this far. Let's see if you can make it through. So in this final project, we're just going to write a simple note program. All right, you ready? Let's start coding. Open up your Aptana Studio or any of your favorite development editors. Create a Ruby project. The project name is Notes. Then create a file. File name is main.rb. So yeah, let's think for a moment about a Notes application. It's not going to be a professional application, but the logic's pretty much the same. It's going to be just a simple console application. So we're going to use a main file as a starting point. But let's create another file for application design. So create a file. File name is application.rb. And yes, we can implement it as a module. Module, application, and it has a run method. Def, self, run. So now we will show a menu to the user, and the user will choose an option to execute something. The menu should be displayed again after any operation, so we can use a loop for the menu. The menu is always displayed until a certain condition occurs. So now let's create a simple menu as a loop. Begin, while choice is not equal to Q, and this means that the while block will run for a while until the choice is Q. So that means we're going to need the choice of the user and then make whatever these operations are going to be in this loop. So why don't we print the instructions, puts simple note application, and then using the center method like we did earlier, that makes it look nice. Puts A, add, puts B, edit, puts C, delete, puts D, show all, puts Q, quit. So let's grab some input from the user. Print, select, choice equals get chomp. And yeah, look at that. The menu looks completed. So in the main file, require application, then application run. And let's test it. So save it and run it. And look at that, it shows a menu. let's check our options. And yeah, look at that. It works great. So let's enter Q again, and the program is terminated. So that was very good. And as I told you before, it's pretty straight up, pretty simple. But right now, let's create an inner class to manage menu operations. Class, menu, and initialize will be our method to implement it. So now let's implement conditionals. Case, choice. When choice is A, then, and now we will call a method from the menu class. So we need an instance of it. Menu equals menu new, then menu add. Yeah, this method doesn't exist yet, but let's implement it. Def add. So, what are we going to need? We need node objects. So, let's create a node script. And we need manager logic to manage the operations. So, we'll create a manager script. And we need a database for saving the note entries. So we'll create a database script. Alrighty, so let's go back to the note file. Yeah, so let's implement the note class. Class, note. And we will create a simple object. We need a text field to save the note explanation, and we can save a date for creating time. So defining the initialize method, def initialize text, and we will set text while creating our note. Text equals text, date equals, we can use the time module to get the current date. Time, now, and we will use a unique ID for each note object. We can use a built-in module, secure random, to get unique values. So why don't we go ahead and import that? Require secure random, and ID equals secure random UUID. So what is this unique value, by the way? Let's check it. And running, yeah, it shows an alphanumeric unique string, and it changes for each run. So yeah, we can use this ID as our application logic. So we need to access it outside of the class. Remember how we do that? Yeah, we can use the attr reader statement. So let's go back to the manager script. Our manager class will operate all operations over the database class. So we need a manager object, and the manager object will need a database object. So create the manager class, class, manager, and define initialize method. Now let's go to the database script and implement it. Class, database, and initialize method. We'll use a file-based persistent mechanism to save node objects. In Ruby, coincidentally, there is a class called pstore. just for that purpose. So I'm going to go ahead and import it, require pstore, and in initialize method, store equals pstore, new, and file name is notes.store. So here is the documentation page of pstore. It has many examples and some really detailed explanation. You can go ahead and check this out. In the meantime, let's get back to the manager class. Create an instance of the database class. Database equals database, new, and we need to import it. So let's go back to the menu class and initialize method. Create an instance of manager class. Manager equals manager new. And we'll need to import it. So now let's implement the add method. The user will enter a text to save it as a note object. Print, note, text equals gets chomp. Then create a note object. Note equals note new text. And of course we should import it. And now we have the note object, so we need to save it in the database. Manager, store, note. Now, of course, there is no store method in the manager class yet, so let's create it. Def, store, note. Now, the manager class uses a database instance to make operations on the database. So, database, store, note. And yeah, there's no store method in the database class yet, so we can create it. Def, store, note. And the pstore manages operations in a transaction block. The transactional behavior ensures that any changes succeed or fail together. Okay, so this can be used to ensure that the data store is not left in a transitory state, where some values were updated but others were not. So this is perfect. Store, transaction, do. Now, pstore pretty much works like a hash. So that means we can set keys and values. We can use the note unique ID as a key. Store as a key, note, ID, and convert it to symbol. And as you may remember, symbols provide better performance. The pstore uses symbols by default. And store the note object. Okay, it's looking good, so let's check the add mechanism. Save it and run. A is for add operation. And the note is, this is a sample note. And no error. Alrighty then, let's check the store file. And yeah, it is created. And its contents includes our note object. Okay, so the add operation is completed. Now let's implement a show all functionality. So when choice is D, then call the menu show all. So let's create the show all method in the menu class. And yeah, the manager class will operate showing entries. So create a show all method in manager class. Def show all. Now we need to get all the entries from the database. Entries equals database get all. And let's create a get all method in the database class. Def get all. Now remember, back in the day we used an array. We can use an array to save all note objects fetched from our database. Notes equals an empty array, store, transaction, do. pstore has a root method to get all keys in the file store. Keys are IDs of note objects. Store, roots, each, a block ID as a block variable, notes, push, store, ID. And yeah, we filled all the notes objects in the store to the notes array. So return notes. Now, as you know, the last statement works like a return statement, so there's really no need to use the return keyword. Now we have all the entries. If entries is empty, then print no entries found. If entries is not empty, then entries, each with index, do, item and index as block parameters, puts, item. Okay, let's call the show all method in the menu class. And let's run the application. And D for the show all operation. And it shows a memory address value. All right, so that just means that we need to override the string method in the note class. Def 2s, and we have a date and text value. So let's return them in a string representation. Date, we saved a date as a combination of the local date and time, so we can show it in a custom format. And for that, we can use the strftime method. Date, strftime, using custom directives y for year, m for month, d for day, and h for hour, m for minute. Oh yeah, let's go right down to the s for seconds. And you can check these on the official documentation site if you want to. And a new line character note, text. All right, so let's terminate the program and run it again. And it shows the note object in our string representation. So let's go back to manager class. We can also show index numbers. printing dashes and each entry index. Indexes are zero-based, so adding 1. Printing dashes below. And let's run it again. Show all. And yeah, it looks good now. Okay, so what about implementing other conditionals? So let's implement an edit operation. When choice is B, then call menu edit. And let's create an edit method in the menu class. Def edit. Now, first of all, we should show all entries to the user to choose from for updating. Manager, show all. And we need to know how many entries are available to edit, right? So we'll create a method to get the entries from the manager. Def get all. Database get all. Now get the entries list from the manager. Call the getAll method over the manager instance. And if the length of entries is greater than 0, then we will use our edit operations. And we can use the index numbers to indicate which note object will be updated. So we can take the index number from the user. Print, enter index number to edit. Index equals gets chomp, and it should be an integer. We can get the current note object using the index number with the fetch method. Note equals entries fetch, and we should decrease the index by 1 because we increased it while showing, right? So the fetch method tries to return the element at the position index. And if the index lies outside the array, the method throws an index error exception. So yeah, let's take some new input from the user. Print note text equals gets chomp note set text. And let's create the set text method in the note class. Def set text 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 equals text, and update the date. Date equals time now. And let's go back to the menu class. Text, manager, store, note. Yeah, we can use the store method for updating too. The unique ID is not changed, so it will be overridden in the database. And finally, show a message for update operation. Puts entry updated. The edit method seems to be complete, but there may be a problem. The user can enter an invalid input, and then the fetch method will throw an exception. So we should take these statements into the begin rescue block. Remember that one? If any exception occurs, we just simply print invalid input. We do not want it to implement any exception handling logic right now. So let's run it again. Edit operation. And let's enter a invalid index. And yeah, it catches the exception and shows invalid input. Edit again. Index is 1. New note is updated note. And it shows entry updated. Show all? Yep. Note is updated. Okay, so let's implement a delete operation. When C, then call menu, delete, create the delete method in the menu class. Delete operation is pretty similar to the edit operation. So we can just copy and paste the entire edit method. Of course, we got to change the print statements. And removing update, related statements. And changing to delete method. So now let's create a delete method in the manager class. Def, delete, note, database, delete, note. Now let's create a delete method in the database class. Def, delete, note. Now we need a transaction statement for deleting the objects in the store. Store, transaction, do. Now pstore has a delete method to remove objects. Store, delete, note. And the documentation says that the delete method takes a name as a parameter to remove the object. And in our case, it is our note object's unique ID in symbol data type. Okay, so let's look over the whole program. Everything looks good. So we can save it and run. Show all. And let's open the store file to follow the operations in real time. Add. Test. And file is updated. Delete. Delete note index of 1. And it's deleted from the file. Delete. Delete note index of 1. And it is deleted from the file. Add. Test note. Show all. And yeah, it shows it. Edit. Edit note index of 1. New note. Delete. Index is 1. And yeah, it's deleted. So quit. So in this project, I just wanted to simulate a simple note application, but as you can see, it took quite a lot to keep it simple. Now, we're always going to want to keep it simple. because more effective solutions can always be implemented. You can always improve the code. So with that, I bid you adieu and go and improve some code.